live from the Walter E. Washington Convention Center in our nation's capital. This is NVIDIA GTC Live, Washington, D.C.
Over the next 3.5 hours, industry titans from a cross-section of the AI ecosystem will gather to share bold perspectives you won't hear anyplace else. And it all builds to the main event, Jensen Huang's first ever keynote address in Washington, D.C.
A historic moment in a monumental city. Strap in. You don't want to miss a second.
NVIDIA GTC Live, Washington, D.C. starts now.
Welcome to GTC Live from Washington, D.C. Over the next few hours, more than 5,000 guests will arrive to attend NVIDIA CEO Jensen Huang's much-anticipated fall keynote address. Before that, we will welcome to our stage 20 guests from all over the world at the very top of the tech industry.
That's right, Brad. They're here to discuss the state of AI, its role in business and science, and the exciting future that NVIDIA and their partners are building right now.
I'm Brad Gerstner, founder and CEO of Altimeter Capital.
And I'm Patrick Moorhead, founder, CEO, and chief analyst at Moor Insights Strategy.
AI is the force for the economy and is rapidly being integrated into every aspect of industry, security, science, and manufacturing.
And that's why we've extended the pregame show to include many of the CEOs, founders, and scientists who are changing the world, driven by NVIDIA innovations.
At Altimeter, we've been big believers in NVIDIA's accelerated computing platform for years. They have been investing in this platform for more than a decade, and the moment is here. AI is taking off, and the world is responding. To help understand what's driving all of this, we have put together panels featuring more than 20 guests, and the lineup is absolute A-list leadership in technology, investing, and innovation. So I'm pretty stoked to be here with Patrick as we kick off this keynote.
And I'm excited too, Brad. And I've spent 3 decades in tech and at Moor Insights and Strategy, 15 years tracking silicon, infrastructure, compute, and software. And what I think makes NVIDIA so special and differentiated and so valuable is its central role in creating not just faster architecture, but what has become an entire AI ecosystem. NVIDIA isn't just selling chips, although chips are awesome. They've built complete AI systems and software stacks that give them a leadership position few can match.
Our goal today is to discuss with these leaders the context and commitment, the wins so far and the challenges to come. So by the time Jensen hits the stage, we'll have a better understanding of what they're doing, why it matters, and what comes next.
It is pretty incredible we have all these guests under one roof, Brad. An extraordinary lineup of leadership from the world's biggest tech companies, investors, that's you, Brad, and innovators.
We'll kick things off with the state of AI innovation, a look at new ideas, open models, and the power of open source that's shaping the direction of AI.
The next panel, Agentic AI for every industry. Intelligent systems are beginning to plan, reason, and act to reshape how industries work.
After Agentic, AI infrastructure ecosystems. Behind every breakthrough is an unseen network of data centers, power systems, and partners, the backbone of the AI economy.
And then we'll move into AI in science and quantum. In labs and research centers around the world, AI is becoming a core instrument of discovery. Now it's converging with quantum computing, where together they're redefining what's possible in simulation and design.
And finally, an important discussion of AI in robotics and manufacturing. The boundary between digital intelligence and physical action is disappearing. Together, AI and robotics are reindustrializing America. This is NVIDIA's 4th pregame show. What began with a handful of the best in tech huddled in a small corner of the SAP Center has grown into this. 3.5 hours, 20+ guests in this massive space here in DC.
It is pretty awesome. That kind of growth is just what you would expect from NVIDIA.
No question. This is the place to be if you want to know where artificial intelligence is headed. The other place to be is on the floor, where CNBC's Kristina Partsinevelos will be joining us throughout the day with even more guests. Kristina, welcome to the show.
Thank you, guys. I have to say, I am quite excited, not because I get to, learn a lot more about anything from quantum physics to agentic AI, but I get to come on the floor over here and really showcase what this event is about. You mentioned this being the 4th one this year. Can you imagine? It started in San Jose, went to Taipei, Taiwan, or I should say, sorry, Paris, and now DC. The difference with this one, yes, it's a little bit smaller, but doesn't mean that we're not going to make a lot of news. You're going to hear from CEOs, breaks the news. I would say just based off of the crowd, it's a little bit darker, a lot more people in suits. That's my only observation thus far, but it doesn't mean that it's not going to be as exciting. For example, what is it, 8:30 in the morning? I've already spoken to the Inflection AI CEO who demonstrated how atoms are staying in place, so just explaining the quantum computing. And this audience, honestly, all of you over here, we thought this would be empty at this point because it's still quite early, but it's incredible that the doors open and there was already an influx of at least 200 people that swarmed in. I promise to break the barrier, the 4th wall. I'm not on CNBC right now, so I can just go wherever, show the behind the stage. You can see Brad over there looking, show everyone so that those that are watching at home or maybe in your office right now, streaming all day, hopefully not flipping to anything else, are really going to get a feel of what it's going to be like. And I say that because not only will I be milling about, that's why I'm wearing the bright suit so you can see me, but I'll also be speaking with several of the guests that come off the panels, from CoreWeave CEO to Cadence's CEO, and we're going to get into the nitty-gritty details of not only what was discussed, but some other topical things at hand in today's day and age. But this is just an example. I would call it the red carpet, but NVIDIA likes to do things differently. That's why it's black. But overall, I promise we've got some juicy details throughout this entire show, and I'll be going back and forth with the guys throughout the morning, I should say, before the keynote at 12 p.m. Eastern. Brad, Pat?
Thanks, Kristina. I feel like we're full squawk box this morning. Well, we'll check in with you in a bit. In just a few years, CUDA has evolved from a programming toolkit into the backbone of the world's AI community. What began as a way for developers to tap into the power of NVIDIA's GPUs has become a global movement.
That's right. Millions of engineers, research, and creators all use the same language of parallel computing to revolutionize AI and drive innovations in every field, from robotics and genomics to filmmaking and, of course, generative AI. And all of this is powered by NVIDIA's vision for accelerated computing. Let's take a look.
You can literally access CUDA wherever you are, whoever you are. We've democratized high-performance computing as we know it. It is the reason why we believe this is the beginning of the age of AI. We now have the fundamental pillars necessary for us to advance artificial intelligence in a way that has never been conceived of before. You are the stars. This is a celebration of your science, of your work, and your innovations. And all of you made this possible.
Behind every breakthrough in AI are the innovators and builders turning possibility into progress. From open models to agentic systems, they're accelerating the next wave of innovation across startups, labs, and markets. Joining us to explore the state of innovation, some of the best. Thomas Laffont, co-founder of Coatue Management. Sarah Gual, founder and managing partner at Conviction. Martin Casado, general partner at Andreessen Horowitz. And Navin Chaddha, managing partner at Mayfield. So Thomas, welcome. Coatue has been investing at the heart of America's super cycles, from the internet to cloud to social. Help us contextualize how AI stacks up and how you think of all this investing in the middle of all the bubble talk.
Yeah, good morning, everyone. Really thrilled to be here and to be the warm-up show. So I know we have a lot of exciting content today. So look, I think that all of the investments have really kind of been focused on infrastructure. So I think when people talk about AI, obviously it starts with semis, it starts with power, it starts with the large language models. I think, if you look at the private markets as an example, most of the value has been accrued at the infrastructure layer for the past kind of 5 or 10 years, let's say. But to me, what's most exciting about the moment that we're at right now is that we are seeing a lot of value be accrued at the application layer. And a new class of companies start to emerge in different verticals. So as an example, if you look at coding, Cursor has become an unbelievable breakout company, one of the fastest growing companies ever. Martin can talk about it as well. That's only enabled to make coding better because of the investments in infrastructure, right? So starting with NVIDIA. But we're also seeing it in medical with open evidence. We're seeing it in legal with Harvey. So to me, one of the interesting moments that we're at right now is all of the investments in infrastructure have enabled apps to come through that are delivering real productivity gains, which I think then reinforces the belief that it's worth making these infrastructure investments because you can see the return from these applications.
Well said. Martin, you're one of the legendary software investors in Silicon Valley. Satya was on my pod last year and made some news when he said, AI is potentially a real threat to software. That software may be this thin interface on top of this CRUD database. And so we've seen a lot of, I think, FUD there. Talk to us a little bit about how you expect software to change, what's winning, and what potentially loses in the age of AI.
Yeah, so I think formal languages came out of natural languages for a reason. And that is natural languages, you can't actually describe what you want.
Right.
So we've always had kind of two stories of software, right? We have the low code, kind of drag and drop, and that is definitely being transformed by AI. I think that's going to look entirely different. But then we also have the very highly technical where there's actual trade-offs, and you have to understand those trade-offs. And, you still need professional developers. If you actually look at AI, the primary use right now in development is professional developers. It isn't kind of casual, if you do it dollar weighted. And so, listen, I think we're in for a major transformation. I think we're going to see a lot more software than we had before. I think many more people will be able to develop than have ever been able to develop before. I think it's a great educational tool, but I don't believe it's going to get rid of software developers. I think this is very much a technical discipline where you have to understand the trade-offs to do it. And so, but I will say, I've been in software for 30 years, and this is the first time we were being disrupted, right? And so it definitely is putting us on our heels to try and understand what's going on.
Yeah.
Makes sense. Navin, great to see you.
Absolutely.
So you made a bold prediction out there that knowledge workers will have what you're calling AI teammates, and that's a $6 trillion opportunity. And I don't know if that's by 2030 or what time frame this is. Can you tell us about what an AI teammate is and how it represents a massive way that we shift in our work?
Absolutely. So our belief is AI is going to team up with humans to get us to superhuman level. And we are entering an era of collaborative intelligence. What's going to happen is AI will manifest itself in the form of teammates, which are nothing but digital companions that team up with us, not only to accelerate productivity, but augment our capabilities and amplify our creativity. If you look at globally, the knowledge worker spend is $30 trillion. So if AI takes 20% of the market, 5 years, 10 years, it's a $6 trillion opportunity. First time, we're not going after IT budgets. This spend is coming at teammate of the people spend for the knowledge workers, and same is going to be the case for physical AI. So we are extremely bullish. It's the same size as the IT market. Now it remains to be seen. Is it 5 years, 10 years? But it's going to happen.
Let me ask a quick question to follow up to that. Is this deflationary at the end of the day, right? Does the $30 trillion market, because we're a lot more productive, right? So the idea is replacement. That 6 trillion will go from humans to machines. But might it also just offer some deflation to the economy, some productivity gains along the way?
Absolutely. So I think in any new information technology market, there is displacement because productivity gains happen. There is some job loss. But in the long run, I'm an optimist. Humans come out as winners. The more productivity gains you get, the more cost savings you get, the more profits you create, you're going to hire people.
By the way,
only difference is basically they won't be doing mundane jobs. They'll be doing things that weren't possible before. And one example we talked about, the vibe coding, 30 million developers have been able to code. So creation has been limited in the form of company creation to 30 million people. Now with vibe coding, which is a teammate, 1 billion people can become creators, and it democratizes entrepreneurship, and we can't even figure out what people are going to do with this technology. So I'm very bullish. Short term, there'll be pain, but long run, the avenues are infinite on what gets created.
It's a really important, we're in Washington, D.C., and at a time where I think there's a lot of confusion on Capitol Hill about the impact of AI. We have too many doomers running around talking about how it might shrink the economy, right? People are going to be displaced, jobs will be lost. It's important for all of us, and now everybody's going to come after us, to come here and educate really on the abundance to come. America cannot stay competitive unless we have our best innovators leading at the front, right? That starts with federal preemption on state laws and other things that can happen here in D.C. in order to accelerate AI. Sorry to interrupt.
No, not at all. Listen, I'm a student of history, and what the history does show is with every major inflection in technology, whether that's engines, electricity, it has been replaced. Now this curve is dramatic, I think more dramatic than we've seen in the other ones. We do need to keep an eye out for it. Sarah, how are you?
I'm great. Thanks for having me.
Absolutely. So you're an AI-focused, AI-native shop, which is amazing, and a pretty good place to be right now. Let's talk about open. I'm curious about how does open drive, let's say, growth? I think we know where growth is, but things like national security, how the U.S. can win by adopting open.
Okay, so I think there's two really important questions here. There's open as an open source, right? As an engineer, but even for everyone who isn't, like the foundational principle of open source is that if you allow more people to participate in innovation, you will get better ideas, you will get compounding innovation, and then importantly, you will open up the market at the layers above that innovation. Right, and so I think the idea of open source and open models in particular allows for more democratization at the application level, where more entrepreneurs can build things that get to actual end users. Thomas mentioned, Harvey in law, open evidence in medicine, Cursor, Martine mentioned in engineering. We're like 1% of the way in, right? What about every other job and vertical? Where are the tools for that? And I think open innovation is going to allow for that. On the national security front, my view as a big believer in America is that we have always won by being strategically open and at the forefront, right? And so I think these things can go together. Strategically open means, like, to me, attracting the capital and the talent to create the technologies that lead and create abundance. Strategically open is deciding what pieces of that we really want to own, both in a supply chain perspective and then what companies really matter and will create opportunities for Americans.
Yeah, it really seems like we should be embracing at the model level all models regardless of where they come from. And of course, we can go in, we can inspect the results to see if there's something going on. But I do think that there's the meme that says we shouldn't be importing models from other countries, namely China, to be able to drive innovation and stacks on top, and I do think that's a mistake.
I think that when I look at it from the application developer's perspective or the end user's perspective, they're going to choose tools that are good for their tasks, right? I don't think you're choosing like a philosophy of intelligence. You're looking for, honestly, efficiency and capability for most of these things. And so I think efficiency and capability can come from all corners of the world.
And let's be honest, if it's driving American innovation, let's have a little confidence in the entrepreneurs that are adopting them.
That's right.
You know, and so we had this DeepSeek moment earlier in the year that I think, again, led people to believe that we can live in this artificial world where we shut down all the open innovation in China and just drive it in the United States. And while I'd like to see, and it's been great to see all the open source models coming out of US labs, the fact of the matter is DeepSeek accelerated innovation in the United States. I don't know, Martin, do you have a...
So listen, I think not having a policy is potentially dangerous here, right? So let's imagine that models were 3D printers. And we allowed anybody to adopt any 3D printer that they wanted, and we decided to limit our own 3D printers. So if our entire manufacturing foundation is based on somebody else's 3D printers, there's a lot they could do, right? They could, you know, modestly shift what comes out. They could only release weaker 3D printers for everybody else, and they keep the stronger ones to themselves. So when it comes to import controls with technology, we've long had long-standing policies, right? Do you remember like the whole Huawei-Cisco thing in the early 2000s? Totally. And listen, it turned out to be very prescient, right? We shouldn't run our critical infrastructure that we rely on something controlled by a foreign adversary in every case. And so I would say first it's important to have a policy. That policy should be nuanced to understand everything that you said. Yes, we do want to benefit from it. Does it go all the way down to critical infrastructure? Maybe, maybe not. Historically, we've done a pretty good job not doing that. And so I think I would recommend being a bit more thoughtful of how we import and use open source AI.
Navin, do you have a comment on this?
Yeah, I think I agree with what was said, but having been in the industry for a long, long time, my belief is the reason openness becomes important is it's an ecosystem opportunity. No one company can solve all the problems. So we have seen with prior platforms, whether it was Windows, Android, iOS, you need a whole ecosystem that thrives and just keeps innovating. So it's not only the geopolitical situation, but for costs and the problems to get solved, you need openness. And I'm a big believer what happened in the past is going to happen again, and companies which are platform companies, which enable ecosystems, will solve problems together. So it's a together thing rather than one company doing it.
Thomas, I want to come back to a question I started with you. Probably the number one question I get asked in venues like this is, how can you invest when every day on CNBC they're talking about a bubble? And, you know, we have had to invest through all of this talk. So maybe just help us understand, where is Coatue investing the most today? Public markets, private markets, early stage, late stage? And how mentally do you guys continue to forge ahead while all of this chatter is going on?
Yeah, I mean, I think if you look at the public markets, for example, one of the different features of this particular market versus the market in the 2000s, which, by the way, we were investing then, we started our business in 1999, is, first of all, stocks are valued very differently today than they were back then. So to me, one of the incredible things about this market is you get to buy some of the world's best, most exciting, most innovative, best run companies like Meta and NVIDIA and Google and others, right? At PE multiples that are on average in the, call it mid-20s on a forward basis, depending on which company you're looking at. Still pretty incredible to get access to all of that innovation at that price, right? So, but obviously what we got to make sure is that we're right about the E, right, in earnings, not just the multiple. So what we look for is leading indicators like ChatGPT as an example, right? And we've seen just off the charts usage. One of my favorite things that Jensen talks about is the triple exponential that ChatGPT is benefiting from, which is more users making more queries and more deep research per query, right? So you kind of get this triple exponential of demand. So I think watching ChatGPT and how it performs across the globe is really critical. But you know, you asked the question about inflation, right, or deflation. To me, one of the defining features of AI is it actually has a chance to bring deflation to sectors that really need it. So I think we've looked at healthcare, for example. You could argue that the internet really didn't do much to bring healthcare costs down, right? In fact, they've continued to increase. I think AI really has the potential to dent the cost curve, right? Companies like Open Evidence, as an example that we've talked about, that make the diagnosis much better. Industrials. How do we bring industrial back to America? Well, we got to get more efficient. We got to get more out of people. We got to get more out of machines. AI can do that. So to me, all of those sectors, we're seeing it in defense, right? Look at new companies that are coming in with lower cost technologies. I think we're going to see that kind of across the globe. All of those things kind of give us the confidence. That said, and there's always a but, we do think hypervigilance is really the key. So we do watch these positions very carefully. We look at all these leading indicators very carefully. I don't think it's a time where you can be kind of complacent.
So Martine, I've got a question for you. We're sitting here, we're talking about AI stacks, and just when it's gone from the GPU to a tray to a full rack, all the software, and now we're talking half the time about how we're going to power these, how we're going to build all these. Where is the leverage the most leverage in the AI stack right now?
I mean, honestly, if let's just say from a national standpoint, we wanted to increase AI throughput, and there's one thing you can do. It turns out that's not technical. The one thing that we can do is ease regulations on breaking ground for new data centers and add power, full stop.
Yeah.
I mean, I think that the rest of the stack we understand very well. That right now is what is limiting our ability to do massive capacity build up.
By the way, Martine, I'm sure you saw yesterday, but OpenAI wrote an open letter to regulators.
Yeah.
Probably worth kind of touching on today, right? But essentially calling for a Manhattan-like project, right, around power generation in this country, right? And looking at all of these options. And look, they called for 100 gigawatts per year, which is a massive number. But I think directionally they're correct, right? Chips need power, and to Martine's point, we need to invest in it.
Yeah, I think we often underestimate what all of this means. We throw around terms like gigawatt all the time. Every time I'm in a pitch, we're like, I need a gigawatt data center. We're talking 4 football fields worth of capacity, right? So this is a major national level undertaking that we need to do. Definitely need public-private partnership and cooperation to do that. But if there's one thing that we can do, it'll be ease regulations on building out new data centers, especially power.
I do think it's also worth noting that there are very few people who believe that America could not benefit from an updated grid.
Yeah.
Right. Every part of it, transmission, storage, new generation capacity, and that there's going to be a surplus to consumers from all of that if it's invested in. And so the fact that there are large buyers of that power that want to front the capex to that improvement in American infrastructure, I think is a really good thing.
I mean, I think, Gurley and I did the pod from Diablo Canyon, the nuclear site in California, that fortunately, amazingly, they were talking about shutting down. It represents 12% of the clean energy, 12% of the total energy in California, vast majority of the clean energy in California. We've gotten that extended. But the reality is the site is situated for 4 new reactors. And we suggested on the pod that Meta, Google, OpenAI, Microsoft could all build their own reactor with a data center right next to it. Those are the type of out-of-box thinking that we need to have in the United States. There are 100 fission reactors under construction in China. Today in the United States, we have 0.
That's right.
Right? And if power is the primitive, if it's power in and tokens out, then we got to get really serious about power, and it all starts here in DC.
Yeah, I would also say, right, we're in the golden era of the semiconductor industry. Beyond the GPU and accelerated computing, not only do you need these new supply of energy, but you can do amazing things on the power and cooling side with innovation that hasn't happened for 40, 50 years. So what goes onto the board with air cooling, liquid cooling, you can do amazing things. And at the end of the day, the voltage and the loss you end up getting. So there is just cutting edge companies being created that weren't happening 50 years back. So it's not only supply of energy, but it's being lost.
Speaking of primitives, Martine, one of the primitives is data.
Yeah.
And, you have been one of the pioneers around the modern data stack, of course, Databricks being one of Andreessen's large investments. Yeah. Help us understand, is AI a threat to, data software companies, traditional database companies, the Snowflakes and the Databricks, or are these things essential ingredients, into superpowering AI?
I think the best mental model for models is that they're data frozen in time. I mean, and you need a lot of machinery and plumbing to get data from the source, which tends to be the natural universe, to these models. And so if anything, it's been a dramatic accelerant. That said, you're seeing kind of a tale of two worlds, right? There's like the traditional analytics data stack, which is all structured and not very AI ready. And then there's the new stuff, which is you just kind of throw a bunch of data at the model and see what comes out at the other end. And so I would say, A, it's a massive accelerant. However, if you're working on data, you need to kind of catch the shifts that are going on because, listen, it's data used in a new way with different guarantees and different bounds.
I have a related question here. So the GSIs have literally millions of employees, and typically what they do is they'll do digital transformation projects, but they'll also modernize, right? And today, modernize. Let's say I'm going to take 27 instances of SAP and put it into one. Do you see a future with agents that would be able to do this? Because where a lot of the training comes from on those is from PDF files and training classes, almost like knowledge bases. Do you see agents as a potential driver to do that with software?
I'll say that. I would actually love to hear Sarah's view on this. But here's my experience looking at a lot of companies adopting AI, which is, let's say 80% of your time is drudge work and 20% of your time is something else that actually involves agency, like knowing what the business needs or knowing what you want or knowing what the customer wants or whatever it is. AI is pretty good with the 80%. It's horrific at the 20%. Yeah. It just really is. And this doesn't matter what it is. So sure, you can do document processing. But my experience over time is, the AI will come, make you more productive on the stuff and be able to focus on the stuff that really matters, and it will increase productivity. And I think we tend to conflate this with things like job loss. We're coming out of 2021, which is this kind of crazy time where you've seen like a massive compression on value, and there's retooling in skill sets. Like the AI companies I sit on the boards of are hiring like crazy. If that isn't an indication that you need people and not AI, I don't know what is, right? And so listen, clearly there's a shift in skill that's happening. That's very important for us. Clearly, there's some kind of macro stuff going on, but my view is these things, yes, will take the drudge work to your question, but they will drive human productivity, not replace it.
I mean, I think that's such an important point. Again, I was on Capitol Hill yesterday having some of these conversations. There was news yesterday that Amazon is having, a major riff. And of course, the question was, is AI causing them to lay off all these folks? And what I reminded them of is coming out of 22, which we described as the age of excess, right? In COVID, companies were hiring like mad. They thought everybody was going to stay home. Getting flatter and getting leaner and getting fitter, right, was important. It had nothing to do with AI.
The most dangerous thing about AI, in my opinion, is that it's an excuse to do slimming, not that it's actually changing productivity.
Right. So I think it's important, that Amazon came out this morning and said, while we are going to get leaner in order to get more competitive, it's so that we can hire more people and double down on our bet in AI. One of the things I want to come back to, we talk a lot about Anthropic and OpenAI. Two companies that, don't get nearly as much airtime when it comes to models, X.AI and what they're doing around physical intelligence, and then Meta. And, I think there was some, commentary yesterday about, Meta was kind of a surprise how little they accomplished on the model front over the course of last year, given their focus. So, Thomas, Sarah, I would love for you guys to talk to us a little bit about the other models that exist out there. Were you surprised that Meta didn't have a bigger impact with Llama 4? And where do you think, the next wave comes from on X.AI, given, that Elon's out there teasing that he may be the first to AGI?
Yeah, maybe I'll talk Meta and then I'll listen to Sarah on the next generation. I think when we talk about Meta and AI, there's a couple just to kind of level set, right? And the first thing is LLMs are broadly not in use at Meta today.
Right.
So if you think about the family of apps from Big Blue to WhatsApp to Instagram and Threads, LLMs functionally outside of small features and threads are not in use today. So I don't think that the bet that Zuck is doing is about, frankly, today, or might not even be about winning the desktop agent war, right? Let's even presume that maybe ChatGPT has kind of won that battle. So why is he choosing to invest so aggressively? Well, I think what they see is a world where one day LLMs are going to be in use inside of all the big apps, right? So you will see generative AI ads, right? Ads that are kind of customized to the individual user, generated on the fly. So we are going to see tremendously more LLMs in use inside of those apps, and they probably want to make sure that that's run on their technology, not someone else's. So I think that's where the investments kind of come from. It isn't just kind of chasing, wanting to be a player on the kind of the assistant side, right? But it's realizing that AI is going to be a core part of all of the infrastructure of their core products over the next decade. That's the time frame I think we should kind of judge them on. They want that to be run on their own technology, but they're also capitalists, and if their own technology can't keep up, they'll turn to others. Yeah. So maybe you can tell us about what you're seeing from the others.
You know, I think your view on XAI depends on whether or not you think this is, like, where you think we are in the model development war overall. If the front is infrastructure, if the front is new architectural breakthroughs, or if it's like capital raising, right? These are all very reasonable assumptions right now. A lot of people would say Elon knows how to build big stuff fast, right? And navigate the regulatory and resource landscape around that. If it's infrastructure, I think X has a very good shot. That being said, this is a period of time where you can't trust the narrative from any individual company that much in AI. It ricochets all the time, but there was a period of time where there's a lot of industry consensus among the leading researchers that scale was all you needed. And that if you just put more compute into pre-training, you would get more capability out. I think it's pretty clear now that the returns to that scale is slowing down, and there might be more efficient ways to spend the next gigawatt of power if we can get it. If that's true, I think it's a much more open landscape, right? And you see really interesting companies like Thinking Machines and Reflection and these new labs staffed by amazing researchers making a new series of bets on different capabilities. I'd also say ChatGPT is an amazing product benefiting from these 3 exponentials. For consumers, whether it's from ChatGPT or from new products, I think we're still like 1% of the way there in terms of the experience that's possible, right? There's still, like, we're at the very beginning of multimodality, figuring out how to make reasoning like cheap and efficient so people actually use it. Very few people use the latest models from OpenAI all the time or from any other vendor. And I think the idea that we talk about agents, and there are some instances of those being used in the business context. They're not broadly used by consumers today proactively. And so I just think we're going to see many more experiences where the landscape of competition is not set between Meta and XAI and all these others. And so it kind of depends on what you think about the research.
I have a question when it comes to ChatGPT and answers. I think that's where most Americans and most users interface with AI. And it's magic. You pull out your phone and you get an answer to almost any question. I feel like the next 10x moment is when that personal assistant can take actions, can book my hotel, can buy my black t-shirts, right? Can do all the things that a great assistant can do digitally. And so my question to you is, when is our agent, when is our ChatGPT going to be able to book our hotel for GTC, where I simply say, hey, chat, book me the Hayes Adams for next Tuesday in Washington at the lowest price? Are we going to see that in the next 6 months?
I think 6 months is tough, but it's just, we're going to blink and it's going to happen, because that's the power of these models, right? Like, not only can they reason, plan, but they have to take action. But there's some missing things on the integration side. No science problems. These are all edge problems, and it's just around the corner. And it is happening in the enterprise first, because you can do manual work, you can do integrations. So we are seeing a lot of cases where some of these things are able to complete the loop and take action and take it all the way. It is going to happen, because at the end, as I said, we're going to have multiple teammates. We are seeing it in sales, we are seeing it in legal, we are seeing it in coding. In the enterprise, it's going to happen in consumer.
I mean, Brad, to me, the most powerful leap will be when it's not just executing the idea, but when it's actually generating new ideas for you.
Yeah.
And I think the Pulse product from ChatGPT is kind of a window into that. So that's going to be the really exciting part.
Well, we were lucky to have you guys. For everybody in the audience, for the absolute best in venture and now leading the charge in AI. It was a thrill to have you guys here. What a great start to the show. And I think what we're going to do is throw it over to Kristina and see what she's finding out there on the floor.
I'm going to turn to an expert and learn more about healthcare. And I'm going to start with Diogo Rau from Ely Lilly, Chief Information and Digital Officer. I actually want to piggyback off of the conversation they just had on stage. They started it by talking about deflation and how AI could bring deflation into healthcare. Could you just speak about how far along that actually really is in terms of lowering costs? Because I'm sure everyone here would love to hear about that.
Thank you, Kristina. It is surprising when you take a look at how long it takes to bring a medicine to market and how much it costs. One of the things that surprised me when I came into this industry is it takes 10 years on average and about $2.6 billion to bring a single medicine to market if it makes it at all. So any effects of a deflationary environment are going to have to be spread over a very long period before we see that benefit.
But doesn't that make it very difficult for you and even your investors, shareholders to really understand the benefits of AI if it's something that's 10 years out?
You are absolutely right, because there's all this talk about AI and drug discovery today, and I think there's this expectation that in 2 years we're going to have a medicine that cures cancer thanks to AI. But the reality is the medicines that we're working on now, we're going to see those benefits in the 2030s at the earliest.
Could you share maybe one particular medicine that maybe that timeline is sped up a little bit?
The timelines are still...
Okay, so there's still there's no
still out
special...
there. We're about 6.7 years within Lilly, and we're doing everything we can to bring them down. But biology just takes time. It takes a while to see how medicine works in somebody's body and make sure that it doesn't have any adverse effects. So it's going to be very hard to speed up the biology, even if you speed up everything else around it.
And in regards to your large language models at Ely Lilly, which companies are you working with to help build those?
We work with all of them, actually. We have over 45 models that we use internally. So we have a platform that allows us to have different models. And one of the things that's great about that is when you have different models, you have different perspectives. So when you have the models interact with each other, they come up with actually very clever ideas, just like when you have a group of people that have different backgrounds.
We were talking backstage, and one of the things you brought up is that you didn't really have experience in life sciences about 4.5 years ago. And you're a techie because you came from Apple. You helped with the Apple stores, the tech, and the retail and online, correct? So how does that translate to Ely Lilly now, 4.5 years in?
Yes,
that experience.
I still consider myself a tech guy, even though I don't get to dress like a tech guy every day.
I have to point out, you're wearing jeans right now. You're not wearing a suit, even though there's a lot of suits here. We are in DC, so we'll give everybody credit for that.
By the way, that's the first thing that I did when I went into the pharmaceutical industry was to change the attire. So like my whole tech team now, they all wear jeans. But really the thing that I noticed the most when I got there is I came from a world where Apple and companies like Apple put the user at the center of everything they do. Literally at Apple, you're starting with the user and you're saying, how do we build an ecosystem around it? I came into healthcare, and do you think healthcare is designed around the user? Like, my experience.
I know the answer. I think our audience knows the answer to that.
And so I think the answer to the healthcare system and how we fix the healthcare system is to start with the patient. And how do we build an amazing experience that's around the patient, not around payers, not around even providers, pharmaceutical or pharmacies and others, but how do we really build that experience that's the right one for the patient?
But then what about patient safety? Because I know that's a major concern. And when we talk about AI, there's some hesitation with some healthcare providers, maybe not to, provide the AI at the patient level because of those fears. So how do you mitigate that?
Well, patient safety is one of the most important things in medicine. Every single medicine company that's out there, they do incredible things to protect patient safety for everything through their trials. So it should be no surprise that patient safety is a core thing that we think about when it comes to data. And so we're not going to do anything bad with data. But at the same time...
Says every company.
Says every company, but I think you can believe some companies more than others. And I would generally trust companies that are in this industry and really care about patient data. But I think at the same time, we're missing a lot of data that AI could be taking advantage of. I've got a watch on here right now. Very few clinical trials take into account how much walking I'm actually doing, for example, or how much activity I have. Instead, they depend on patient-reported outcomes, like how do you feel today, or other things like that. there's so much opportunity to bring more data and more AI into our clinical trials and hopefully develop better medicines.
You just mentioned data, and that will be my last question in regards to the data that you're sharing with biotech firms. So you're opening up some of your models, right? About 17 to 19 of them. So how does that work? Like they get to use your models, but then you get some of their data. So it's like, it's a freemium model almost in a way?
Well, here's the interesting thing that I never thought about until I got here, which is we've got so much data, millions of molecules that are really well described. Most of those molecules, almost all of them, don't work. But if you're going to train an AI model, you need the things that don't work. Everything that's published out there, if you go to public data sets, are all the molecules that do work. And so what you really need is a lot of stuff that isn't actually good and helpful. So we've got tons of data, but we've never figured out how to make it available to the rest of the biotech ecosystem. Now with federated learning, the concept of sharing your data in such a way that you train a model while keeping the core data, the source data private, you don't have to give away your trade secrets. And that's what we're doing with biotechs.
Right.
So we're able to build a model together without exposing our data.
And that's an actually excellent way to end, right?
Yes.
All about patient safety, not and sharing data. Diogo, thank you so much for being very honest
Kristina.
about the timeline, too. I appreciate that. Guys, I'll send it back over to you.
Thanks, Kristina. We'll check in with you in a bit. You know, when people talk about winning the AI race, it's not just about faster chips or bigger models. It's about scale and deploying the American technology stack across the world.
That's right, Brad. From semiconductors to frameworks, from the cloud to the developers who built it, I believe America is currently winning that race. And that dominance in AI is really fueling a new era where millions of AI agents will exist to help us in every part of business and in life.
So let's take a look at all the possibilities.
In the future, there are probably going to be 10 billion digital workers. We'll have AI agents, which are part of our digital workforce, working with us side by side. AI agents will be everywhere. How they run will be fundamentally different.
AI is no longer a single application. AI systems now decide, design, and deliver. Across sectors, autonomous agents are transforming how work gets done, from strategy to execution. To discuss how agentic AI is transforming every industry, we've put together another incredible panel, starting with Aravind Srinivas, co-founder and CEO of Perplexity, Shiv Rau, founder and CEO of Abridge, Scott Wu, founder and CEO of Cognition, and of course, George Kurtz, the founder and CEO of CrowdStrike. You know, Aravind, let's start with you. Nobody has innovated more on the chatbot, on search, on the browser now, in AI than Perplexity. You've consistently been a step ahead, although fighting maybe up a mountain against bigger incumbents. So tell us now, what comes next for the agent? What do you see out there? What is hiding in plain sight?
Yeah, first of all, thanks for having me here. What is really our vision for the browser is not to launch yet another browser. We think of Comet, our browser, as a personal assistant for all of us here. Essentially a second brain to delegate all the mundane, boring work. So it gives us a lot more time to explore and just be ourselves on the web. The internet is just a lot better if you can ask questions from wherever you are. Whether you're on a web page, or you're in a Google Doc, or you're in your Slack workspace, or you're actually on an AI tool, it doesn't matter. You can just ask questions from wherever you are. So that's what we learned first time when we launched Comet. the number of questions a user asks on Comet is 6 to 18x more than what they ask on Perplexity and on other browsers. So that's just because the AI is there with them everywhere. And they're starting to do a lot of awesome things like setting up their own Shopify stores, setting up their own Facebook ads, listing items on Facebook Marketplace, all those sort of things. So we're just beginning to see this explosion of people getting a lot more agency and autonomy on their own.
I think we're just at the beginning. We're going to come back and talk a lot more. I'm going to ask you some of the questions I asked the last panel on when I'm going to get my agent to book my hotel for me, and I know you have opinions on that. But Scott, Cognition's one of the fastest growing startups in history, building coding agents that are helping to power some of the country's largest enterprises. There are a lot of people worried that the AI hype is ahead of the substance, right? Yeah. You're on the front line selling to America's biggest enterprises a solution that's helping improve their business. So from those front lines, help us understand, where is the substance of AI coding today? How is it transforming these companies? And do you think it's going to keep up with all the excitement and hype?
Yeah, absolutely. No, I mean, I think right now, in code especially, you really feel this, which is you are just faster as a software engineer if you're working with the best AI tools and doing the most with that. And there's a range of kind of the productivity gains you see on different use cases. On some of the more kind of gritty, very particular use cases, you might see speed ups on the order of 20%, 30%, 50%, something like that. For a lot of what we call the engineering toil, that's things like migrations and replatforms and modernization. Honestly, we're seeing gains that are in the neighborhood of 6 to 10x, where basically 1 hour of an engineer's time using the best tools corresponds to about 6 to 10 hours not using the tools. And so, I think the gains are very clear, and I think the thing that's really exciting about it is every team everywhere has so much more software to build, and that's the best part of it, right? And every team has, you told me this, I think, a year or two ago, which is every engineering team out there has 50 projects that they want to go work on, but they have to choose 4 because that's how things are with engineering, right? And so, the ability to speed up and to do a lot more is really, really exciting for us all.
So Shiv, I was fortunate enough to spend 10 years on the board of Austin's largest hospital. And I was the tech guy coming in, and man, it was like time stood still. Things were slow, getting paid for things. If there was a box sitting in the hallway, you would get JCO to come after you. I'm curious though, with all those pressures inside of our healthcare systems, how is AI putting the patient in front of the line here? Because sometimes that gets overlooked in the bureaucracy.
Yeah, absolutely. Well, it's been a wildly historic moment for AI in healthcare over the last few years. And part of the moment is the problem, is the pain point. 2 out of 5 doctors don't want to be doctors in the next 2 to 3 years. There's a JAMA article that suggested that 30% of nurses don't want to be nurses in the next 12 months. So we have a public health emergency. We have to do something about it. And that's where AI comes in, because AI, and in our case with Abridge, we're able to unburden clinicians so that they can make eye contact, so that they can be fully present with their patients, knowing full well that a lot of the clerical work that they've got to do, that's getting taken care of for them, so that they can just focus on the person, focus on the care that they're delivering.
That's incredibly valuable. George, great to see you.
You too.
Thanks for coming on. So in every major inflection point, whether it was mainframe to mini to client server, PC, social, local, mobile, we fractalized our applications and our software. And what happens in every one of those is security gets more difficult. How in the age of AI is the risk higher? And then how is AI using to actually help be more secure?
Well, when we think about technology, and this is the great part about where we are today, if you look at the slope of the technology innovation curve, security has to parallel the slope of that curve. So in every inflection point that you just mentioned, you have to have security. 30 years ago, it was an afterthought. It was a bolt-on. Now, thankfully, it's being integrated into the stack. And I think what we've seen over time is where security, where technologies have sort of seams, that's where the adversary lives, where you're trying to connect things together. So if we can build it in foundationally, it's going to be much better off. But from an AI perspective, what does it really buy you? My view is that data is the key to solving almost every security use case. So the more data you have, the more use case you can solve. And obviously, AI seems to be a good opportunity to deal with lots of that data. So, from our perspective, what we try to do and what we've seen in the adversary universe is the time has dramatically been cut for the adversary to actually be able to find vulnerabilities, exploit them, get in and pivot. It used to be months, then weeks, then days, now minutes. And in one of the cases, we found within 51 seconds, an adversary had dropped onto a system and pivoted off. So the only way you're going to keep up with that is the automated SOC, the AI native SOC, where you're driving AI agents doing the work of a security analyst that cannot keep up with the threats. And the challenge that we have right now is that AI, in many senses, is great because we're able to deal with these threats, but it's minting new adversaries because it's now democratized destruction, and it's given this level of sophistication to a much broader group that are not as sophisticated.
So George, I'll call it the value chain of security threats goes all the way from a $5 IoT endpoint to the hyperscaler data center and everything in between.
Yeah.
I'm curious, is there a central place that we can secure everything, or do you need to have these every step, every link, let's call it confidential computing?
It's not an easy problem to solve, and if you think about it, I always jest, I'm on all these panels every year, and for the last 30 years that we still talk about bad passwords and identity. Like, we still haven't solved it, right? I mean, that's kind of the state we're in. We're getting better. But you have to look at where compute happens. Obviously, cloud is a big element, but now with AI, it's being pushed more to the edge. It was at the edge, and it's in the cloud, and it goes back and forth. Now it's all over the place. So from my perspective, you've got to apply the right security technologies to each of those technologies, and then you got to connect the dots across them. There isn't one magic bullet that's out there. There isn't one company. There isn't one technology that can secure everything. So it's using the right security for the right technologies at the right time.
Shiv, when you think about, I love your story, right? A cardiologist by day, and leveraging AI agents to solve healthcare problems by night. Today, it's about translating those doctor-patient conversations into the health record. But when you look ahead and think agentically, where is AI going to have the most impact on your practice? What are you most excited about as the next step for Abridge and what's happening out there?
Yeah, absolutely. I think a big part of our thesis is that in the next 5 to 10 years, we're not going to be able to fully automate a doctor or a nurse. Yes. And if we're not fully automating them, then the conversations that they're having with their patients are really upstream of so many of the workflows that happen in healthcare. So if I see a patient in clinic, I'm without this technology, my back turned to them, I'm not really paying attention to them, I'm typing the whole time, I'm not really making eye contact, I'm not being present. With this technology, I'm fully focused on them, my documentation's getting done for me. But also in this country, but around the world, we're not, as clinicians, compensated for the care that we deliver. We're compensated for the care that we documented that we deliver. Yeah. So essentially, these notes are bills in healthcare. And being able to generate the note the right way, in the most compliant way that checks off all the boxes for those billing and coding experts, as they call them, means that you can keep the lights on for the health system. Now you can start to remove any amount of waste in the system that is basically taken up by inefficient offshore services.
Go ahead.
Scott, the meme out there is that developer tools are going to mean that we don't need any developers anymore. And, it's funny, if you go back to the old days, machine language to COBOL, once COBOL showed up, it was, we're not going to need any more developers. But what happened is every successive generation of tools, we moved to IDEs, and now we have some pretty amazing products, including yours, that can help do code assist to accelerate time to good program, and a lot more. I'm curious, what's the end game here? How far can this be pushed? Is it like we saw with the other iPhone, the iPhone meme, which was all photographers, no photographers are going to have a job. And I see photographers out there, but what it did do is smartphones did democratize taking pictures that looked, pretty good. So how far does it go in the programming space?
Yeah, no, it's a great point, and to your point, I mean, I think software, it's assembly and COBOL, and maybe a long time ago it was punch cards, and obviously now we have
I did that.
Python, and we have and things are running on the cloud, and there's been a lot of form factor changes. But I think if you think about what is software development, at the end of the day, all you're trying to do is it's telling your computer what to do, right? That's kind of how I would describe programming, software engineering, whatever you call it. It's telling your computer, here's exactly what I want it to do, and having it go and do that. And I think it will always be up to us as the humans to decide what the computer should do, right? And I think getting to this kind of platonic ideal where you can really just work with your computer, Jarvis style, and tell your computer what to do is where this is going. And I think people talk about Jevons paradox, right? And I think code is perhaps the best example of it, which is, again, as you're saying, we've already made software so much more efficient over the last several decades, right? I mean, every software engineer, what we all love doing as programmers is going on and automating processes and figuring out how to make this part faster and make this cleaner and simpler and so on, right? And despite that, the number of software engineers has just gone up and up because we have so much more demand for software.
Aravind, as you think about, as you know, one of the places I'm most excited is how this is going to transform the consumer experience. I think all of us have come of age in the age of 10 blue links, right? And Google was such a breakthrough in terms of information retrieval, transformed all of our lives. But for my 17-year-old, they wouldn't dream of spending their time looking at 10 blue links when they could just get answers. Where do we go? I asked the question on the last set, when am I going to be able to book my hotel in DC and just talk to Perplexity or talk to ChatGPT, say book it next Tuesday at the lowest price. It already knows what hotel I like to stay at. It already knows the room I want. How far are we from actions, not just answers?
Few months to actually do that particular prompt you're asking for. So hopefully next time you come here, you can use our product and get it done. But here's the thing, 3 years ago, we started this transition from 10 blue links to answers when we launched. And it had a big impact in the sense that even Google is starting to do the same thing. But the real transition entirely from just going and booking your hotel through a keyword on Google to just asking your agent to go do that for you is only going to be possible with something like a browser agent. So that's essentially why we wanted to build Comet. And essentially what you're talking about is it should have a deep understanding of you. It's your personal AI, so it should have a sense of what rooms you like, what kind of views you like, what is your budget, where do you typically stay, what are the set of hotels you typically stay in case it has to deal with constraints on availability. And then it has to actually go to the website of the hotel and check for these availabilities and actually go and use your card and make the transaction on your behalf. So it's essentially advantageous for a company like us, which has access to the web. We have our own index, we have our own browsing infrastructure, to be able to do all this with the help of the most capable frontier reasoning models. And as these models are advancing in their reliability and their capability every few months, it's possible to actually create this end user experience. And our goal is that, even if it takes a few minutes to get it done, you should be able to take your mobile app and just speak out this task, forget about it, delegate it. It's running on the background on the server, asynchronously, comes back to you, elicits feedback whenever it's not sure, and actually gets stuff done. That's our vision for the mobile version of our Comet browser. It should be running on the background asynchronously and able to multitask and do hundreds of different tasks like these.
There's been a complaint of some browser-based agents that they're just slow, right? They go in, they kick the tires, and I needed to get groceries, and my gosh, it didn't fully understand what I wanted, and I could have done it quicker. Very related, I think, to your travel. When will we get to the point where it's faster, or is that not important because it can be doing it in the background?
Yeah, so that's the key distinction between agents and chat. It's not necessary for agents to be living in the chat UI. In fact, it should be more asynchronous and running in the background. Chat is synchronous interaction. So when you give your coworker or an intern or your assistant a task, it's not like they finish it in 1 second. So why would you want the AI to do it?
Definitely not my interns.
Yeah, but the key point I'm trying to make is it can parallelize, you can multitask,
right.
You can do hundreds of tasks. You can call a plumber, you can call 5 different plumbers at the same time, find the best option for you, whoever can come earliest at the best price, and get it done. It's basically humanly impossible to do 5 calls at the same time for one person. So that's the kind of thing that we are imagining for agents. It's still not a paradigm that everybody's used to, where you ping somebody on Slack, give them a task, you don't expect them to reply instantly.
Sure.
But on a chatbot, you want the answer fast, and you're like, oh, this product is pretty slow. It's slow because it actually physically takes time to get things done.
Great points.
George, I think security is one of the most important areas in AI for part of the reason that you laid out, which is we've democratized the business for attackers.
Right.
2 questions. Number one, if data really is kind of the primitive to AI being able to help defend, then does this mean that advantage goes to the security companies that are at the largest scale, that have access to the most data? So I've heard your company, I've heard Palo Alto talk about platform systems now increasing advantages of scale. And then the second question, I think, is if you're a startup, we're an investor in Expo, which is, build an AI hacker to help companies offensively try to get ahead of this. Do startups have the opportunity, given that scale disadvantage, to continue to be the disruptors in security that they've been in the past?
Yeah, 2 good questions. So I do think scale is incredibly important now more than ever. When you look at competitive advantages and moats, one of them is scale. It's just, not only the amount of data you have, but the customers you can touch, right? And that's the whole platform play, as you know. I think from a data perspective, there's a lot talked about, well, we collect data or they collect data. It's how you collect it, it's how you curate it, it's how you label it, and it's what you do with it. It's not just a pile of data. And the context is really important. And one of the things that we focused on since I started the company was never losing the context of when we collect data at the endpoint to the cloud. We've got a mini graph on the endpoint, we've got big graphs in the cloud. We never lose context. And this is the key. It's not about collecting a pile of data and putting it somewhere. It's never losing the context. That's number one, and I think that has served us well because it allowed us to solve new use cases by creating new modules and with very little effort in terms of the modules that we add on, right? Because we've already collected it once, and it ties into the business model. I think with respect to startups, I think it's one of the best times to be a startup. There's so many things that you can do today in security that you couldn't do. We had to build all this stuff, right? We were like pioneers in AWS. They didn't have all these services. We had to build the hard stuff. We couldn't use all these APIs and services that were out there. So I think, the startup you mentioned, Expo, is really cool because now they're at the top of the leaderboard for finding vulnerabilities and with all the bug bounty programs. It's actually really cool technology. So if you're a startup in security, I think you carve out your niche. You have a lot of advantages that we didn't have, some of the bigger players. You have speed as your advantage. And you can connect to all these APIs that just weren't available. So if you do what you do really well, either you're going to get really big and expand horizontally, or you're going to be part of a broader company. 2 good outcomes. But I think now is one of the best times to be a startup in security because you can focus on the areas that really matter. And then companies like ours and others that are out there look at those and go, okay, we want that to be part of our platform.
George, I want to up-level a little to, we're here in DC, obviously. Is there something that Washington can do to help make our country more secure in this new age of AI?
There's a lot that we can do. I had some meetings already yesterday. I think there's 2 things. One is there's a technology piece, which I'll come back to. But the first is the procurement piece. And in most cases, and I've been selling in Washington for the better part of 30 plus years, is they're buying technology that's 5 years old because their procurement cycles take so long. It takes forever to get through it all, right? So we've got to come up with a better way to procure these. And instead of most big enterprises, you guys deal with them, you know what they do? They buy once for all their subsidiaries and their companies. In the government, it's a little piece here or there, and it's just piecemeal. So they've got to figure out the procurement. And then on the technology side, they need to be forward-leaning. And I think we're in a position currently now with this administration where they are forward-leaning. They think like a business, right? Not like a government. And the key is they need to be implementing the Agentic SOC. They need to be pioneering areas that haven't been done before with companies like ours and others to drive automation and implement technology that's, future for the next X number of years, not technology from the last 5 years. So if you combine speed of procurement with the ability to deploy technologies and partner, public-private partnership, I think we can get to what I would call security AGI. This is my goal. How do we get to security AGI, and how do we create the autonomous SOC?
I mean, I think it's a really important point, and of course, our AIs, our David Sachs is looking for ways that he can drive further efficiencies in the administration, and I think that's a great example. Procurement's not sexy, but if we're buying technologies that are 5 years old in the age of AI, in AI dog years, that's like 50 years.
Exactly.
And so that's a suggestion we'll certainly take to him. I want to come back to this just question we had on the last panel about, you know, power and the primitives and the cost of inference, right? All your companies are big consumers of inference. What do you see happening in the cost, that effectively is a cost of goods sold for many of your companies? What do you see happening in the cost on the inference side? Are we bringing down the cost fast enough? What are things you might be doing creatively with clouds, with on-prem, et cetera, in order to drop that inference cost? Or is it something that you think about at all? Maybe starting with you, Aravind.
Yeah, so I think like a lot of people predicted the costs would roughly half every 3 months or something like that. I don't know if that trend is still continuing. Costs will continue to drop as good models continue to emerge. For example, you could see Haiku 4.5 from Anthropic was pretty good. What we're doing is driving a lot of our own inference workloads. So we work with NVIDIA and building our own inference libraries, and we use that to serve the best open source models. We collect a lot of tokens from all the several tens of millions of users that we serve, and we use that to like post-train our own versions of these open source models and serve them, and that helps to bring down the cost a little bit. We are really hopeful for GB200s to be like, much more efficient compared to the H200s that we are currently serving on. And that's hopefully going to lead to some reduction in cost too. In addition to that, we're also introducing new subscription tiers. So we have a Perplexity Max subscription, which costs $200 a month. But we're introducing the concept of background agents there. Agents that will reply on your behalf on your emails, draft your replies while you're sleeping. You can just add that agent to your email thread and just schedule your meeting for you. Automatically tag your emails as different categories. Imagine that sort of agent booking your tickets, booking your flights, booking your restaurant reservations. I think $2,000 a year is pretty cheap for something that can do all of this in parallel at the same time with all your personal context, right? And that's going to obviously need a really frontier reasoning model that's going to be expensive to serve, but you're going to make way more in return because people are going to use it to make their life a lot better.
Scott, maybe for you guys, what are you doing? I know a lot of the deep reasoning that you're using consumes a lot of inference. What are you seeing out there, and what are you thinking about in the world?
So one big thing to call out is, agents especially are extremely compute hungry. And maybe one way to think about it is, you go to ChatGPT and you say, all right, who was the 4th president, right? And it gives you the answer. That's one query, one answer, right? If you go to Devin and you say, hey, I've got this bug, can you go click through the product yourself, reproduce the bug, check the logs, see what went wrong, maybe try and make some fixes, and then go and test the code and make sure all that works. That's hundreds of queries or even thousands of queries that come from just one human ask. And so, for better or for worse, they are extremely compute hungry. With that said, the way that I like to say it is the productivity gains that we're getting are so massive that obviously, we're not going to have the GPUs and just say, oh, just turn off the GPUs. We're not getting enough value out of them, right? And so I think a lot of what it looks like is kind of optimizing on that spectrum. And I think the models are getting smaller and faster and smarter, all the time. But maybe one thing I would point out is there's kind of this curve of intelligence that always exists, where the absolute smartest model that you could have is also pretty slow and bulky and so on, and then you have something maybe that's almost as smart but is much faster, and then you have like a really, really fast one that's that next level. And one of the big things that we have to think about with Devin, because Devin is a compound system that uses multiple models, is basically at each point in time always using the right model for the job, right? And so, hardest step of this debugging problem, you want to put all the reasoning into it. You want to do the smartest thing. If it's just clicking around the website and doing steps 1, 2, 3, something that's fast and just kind of like efficient gets the job done, right? So it's kind of finding that mix between them.
So, this ensemble model approach is a mechanism you're deploying in order to not only drive down the cost of inference, but drive down the cost of model use.
That's right. Yeah. So you're able to kind of use this frontier of models where the biggest and most expensive models you only use in the times that you absolutely need them, and then for a lot of these other kind of day-to-day tasks that don't need the maximum intelligence, you're able to do that faster, cheaper, and so on.
There's a lot of chatter out there that Cursor may be building their own model or attempting to build their own model. Is that something in the future for Cognition as well?
Yeah, so we do a lot of post-training of our own of various models, and we produce models that are really well suited for our particular tasks. And I think especially when you get into the depth of software engineering, obviously, a lot of the models have a lot of code data trained into them, and that's one thing. But if you said, hey, my Kubernetes pod is going wrong, and could you please just take a look at my logs and see what happened? That's obviously a very specific task, which you can train a smaller and faster model to do very well. And so, specialization of task is where we see a lot of this model training coming to play.
So Shiv, I mean, healthcare, the expenditures are massive, but there's so much pressure. How does the cost of inference impact you and what you're doing at Abridge?
Yeah, it's a similar playbook for us. We're live in over 200 of the largest health systems in the country. We're touching well over 70 million patients, every year. And we're going really, really deep on a very narrow use case, but it allows us to get a lot of edits from users on a daily basis. So our playbooks are similar in the sense that we might hit a model maybe 19 times, let's say 20 times, to create one set of outputs for any given doctor-patient encounter. If all of those hits were to an off-the-shelf commercial model, we'd be out of business, obviously. And so much of our playbook is around distillation, it's around open models, it's around fine-tuning, and it's around post-training. And so being able to even create that feedback loop in healthcare is easier said than done because of obviously privacy and security being so important. This information is sacrosanct. So a lot of what we have to do is build pipelines that allow us to de-identify data, then certify that we've done it the right way, and then build the systems that allow our models to continually improve with every single encounter across the country.
Aravind, I'm going to give you just a softball question. Just kidding. So there's been talk about agentic systems replacing operating systems. We've heard Meta talk about it. I've heard Qualcomm talk about it. Anybody with a headset as well, an XR headset. What is the odds or the chances that this could become a reality?
So could you repeat that? Sorry.
Yeah, so essentially, instead of having a full-blown operating system like we have with Windows, iOS, it's an agentic system replacing it.
Yeah, so the way we think about it is the browser, one of the reasons we decided to work on a browser is there's no other way to ship a personal agent on the phone. Because the phone, there's only two operating systems that you can have on your phone. It's either iOS or Android. And while Android might appear like an open operating system, technically it's not, because what actually gets shipped on the device is controlled by Google. So the browser lets you access third-party apps without actually having to do that at the OS level on the phone. We think cracking that problem is way more important than going out and building a new hardware, because your new hardware should still connect to your phone via Bluetooth, and you're still controlled by all the permissions that your OS on your phone lets you do.
I appreciate that. Yeah, Johnny Ive is working on that. It's OpenAI right now. It's not necessarily a device like this, but who knows? Is it a headset? Is it a pair of goggles?
By the way, I'm really bullish on other hardware. Like the glasses are a really amazing form factor to just visually see things and like ask questions based on what you see. That totally breaks the interaction mode of just asking things from a stream of text. At the same time, I feel like access to the web, access to browsing, access to tools, these are not going away. So you've got to work on problems that are hardware agnostic as a software company.
Makes sense, browser-based.
Well, I would say we could sit here and spend another 30 minutes. Some big news this morning out of OpenAI, Microsoft, what they're going to do in healthcare. So I know you guys need to get off set and to pay attention to the stuff going on in the world, but it's been great to have you here. Thanks for spending time with us. And let's continue the conversation on the floor. So in the meantime, let's go back to CNBC's Kristina Partsinevelos on the floor with another amazing guest.
Yes, one amazing guest, Mike Intractor, the face, founder, chairman of CoreWeave, one of the 3 founders, I should say. Mike, we've been talking for quite a bit, and there's so much I want to share with our audience, but could you speak to just the relationship with the government? And we're talking about these build-outs here. You guys are clearly building out a lot of data centers. How is that relationship changing, even now and in the near term?
Yeah, so CoreWeave has been building the physical infrastructure as well as the software stack for the most demanding, most sophisticated consumers of accelerated compute in the world. And we are relied upon by the labs to deliver that infrastructure. And we're incredibly excited to be able to deliver that infrastructure to the government, to the federal government, the state government, the local governments that are going to need to access this infrastructure as they continue to integrate AI into every aspect from, across society, through defense, through security. And we just really think that a purpose-built stack like the one we have is going to be incredibly productive for the government, and we're excited to build that business.
Do you feel like you need more support, more help? We were talking about public-private partnerships. Getting the picks and shovels in the ground has really been an issue. Power has also been an issue. You are facing all of those issues. So how do you mitigate that when you're promising to build out 2 gigawatts here at Project Horizon in West Texas? How do you deal with that?
The challenges of building this infrastructure at the size and scale and speed are material. The government's role for us is to help us facilitate the permitting process. The role for them is to understand that this infrastructure is of national importance, national security, national priority, and to be able to support us as we continue to do that, whether it's through public partnerships, whether it's through tax abatements. We need to build this stuff, and we need to be able to tap into the capital markets to raise the money to be able to build this stuff at a speed that has really never been contemplated before. And so it's a really important role that government comes in and supports CoreWeave and supports other companies that are driving the infrastructure that the country and really the world needs to be able to allow artificial intelligence to achieve its potential.
You actually just mentioned tapping capital, and that seems to be a constant theme, right? How levered CoreWeave is. And you just recently announced this partnership with a Paris AI startup, backed by NVIDIA, poolside, and the goal is to provide 40,000 GPUs. How is the debt going to, how are you going to build that out? Because that requires a lot of upfront CapEx, a lot of spending.
We've been the tip of the spear in many ways in building debt structures that allow us to go out, find a client, structure payment from the client, go out into the debt markets, buy the infrastructure, build it, and ensure that our payment or repayment of the loans occurs within the 4 walls of the contract. During the 5 years or 7 years that we go ahead and we contract for, we're able to pay for the infrastructure, pay for the OpEx, drive a return to our company, reinvest in the R&D associated with building the next generation of technology. And it's been incredibly accretive to our company. We've been pushing this debt structure out into the market because we think that this is the way you build large-scale infrastructure over time. We're excited about it. Poolside is a great client. We're really excited about them as an offtake for our compute. We're really excited as them as a partner as we continue to build physical infrastructure and data centers with them.
But building over time, you're signing leases for some of these data centers for 15 years, and then there's concerns that the customer contracts are much shorter, so that leaves a gap. How are you dealing with that gap?
Yeah, you're correct, right? Like there is a timing mismatch between the current contracts. But the truth of the matter is the world's going to continue to need compute. They're going to need the data center infrastructure. And as a company that has been built on our ability to quickly respond to the demands of the computing infrastructure globally, we need to have access to those data centers to be able to serve the needs of our clients. We will continue to do that. We will continue to build the infrastructure. We're really excited about it. We think it's an appropriate risk for us to have.
And I guess we should just end on that because it was a nice positive note. Mike?
Seven o'clock. Okay. Thanks, Kristina. AI isn't just transforming tech. It's becoming a new driver of the American economy. From manufacturing to medicine, it's rebuilding our industrial and scientific foundations that are driving new productivity and new jobs.
Oh, it's me. Nowhere is that impact clearer than in the rise of data centers. They are the new factories of the AI age. Here's how this wave of innovation is fueling record growth across the U.S.
The world is going through a transition in not just the amount of data centers that will be built, but also how it's built. In just 1 year, you could see the incredible growth in AI infrastructure. The computer has become a generator of tokens. I've said before that I expect data center build out to reach $1 trillion, and I am fairly certain we're going to reach that very soon.
America's AI leadership depends on more than algorithms and chips. All those are awesome. It runs on infrastructure. Data centers, power grids, supply chains are becoming the backbone of intelligence, the foundation of a national strategy for innovation. Even when we assume we need, let's say, 1,000x more, and there's forecasts that go up to 1,000,000 times more, the build out is tremendous. And here to talk about building that foundation is Gio Albertazzi, CEO of Vertiv, Olivier Bloom, CEO Schneider Electric, Krishna Janalagagada, CTO GE Vernova, and Chase Lockmiller, co-founder and CEO of Crusoe. All right, Gio, let's start off with you. And let's pretend for a second people don't know how big of a challenge that we're looking at right now. Can you talk about the scope of the power and the cooling that we're going to need by, let's say, 2030?
Well, think in terms of all the announcement that we have heard about investment in data center, certainly in the US, but globally. We have an imagination about how much IT power is behind that. Yeah, for every kilowatt, megawatt, gigawatt, there is an equivalent amount of power and thermal infrastructure, and that power and thermal infrastructure needs building at scale. Now, that has been traditionally a very kind of a construction, labor-intensive industry, and we're all thinking about how can we change that and scale it to absolutely unprecedented industrial proportions. Because without that, and that's what I believe, and I know everyone in this panel and beyond are doing, without that, we will never be able to scale AI at the speed that we have seen in the video and that you have explained to us. And so I think we are at a very important inflection moment in this juncture.
So, Olivier, Schneider has been a hallmark inside of data centers. I get a lot of data center tours, and I see your logo on a lot of the boxes in there. One question I have for you is, sure, it's build more and more and more, but there's also an efficiency play. Can you talk me through the balance of efficiency and just more power?
Yeah, you're absolutely right. You know, what is very interesting, we are at a time where AI depends on compute depends on energy,
But the very interesting part is energy availability and efficiency depends on AI.
Okay.
Because you know, at Schneider Electric, we have been an advocate of energy efficiency for many, many years. And we strongly believe that the combination of electrification, automation, and digitalization will solve the energy transition in every part of the world. Now, 10 years ago, frankly speaking, it was not possible. Electrification, automation were available, but the type of technology you have now through AI help you to make energy more efficient. So on our side, of course, we are excited because altogether we are providing the infrastructure to make the compute and therefore AI available. But we are even more excited to leverage AI to make our overall industry more efficient. And if you think through, we have been all of us through the industrial and digital revolution. Actually, what we are doing, it was in your introduction, we are talking more and more about AI factory, and we are implementing exactly the same principle. So going through the full life cycle of this AI factory, start from the design, building digital twin, where you can simulate power and cooling efficiency, to the development, the construction, the maintenance, the operation. This full life cycle is completely powered by AI at the end.
Krishna, I think that you know, Vernova's gas combustion engines are really a secret weapon in America's AI build-out. But you're sold out. And, you know, talk to us a little bit just about how you're changing your own business processes to drive more production, to get more online, and how you see that playing out over the course of the next few years.
Oh, sure, Brad. So, like you said, the production is, you know, the demand is massive. We are sold out through 28, maybe through 29. But we're investing heavily in capacity expansion of gas. So we're quadrupling our capacity of, you know, number of gas turbines delivered by 2028 compared to 2020. And this is, all types of power is also an answer to this. It's not just gas. Yeah. So we are fortunate to have basically all kinds of power that's available to us. This is gas, this is nuclear, this is solar, wind, and hydrogen. So we are looking to leverage every type of power source that's available to grow the electrical infrastructure. And power generation is a part of it. A big part of it is also, we'll talk about later, is the grid. Once you actually generate these electrons, how do you get them from source to use? In a very complex environment with new grid resources and so on. But power generation is definitely and grid is a big bottleneck right now, and we're working on, you know, easing that.
Help us understand how your power generation capabilities, capacity evolve from 2025 to, let's call it 2029.
So if you look at the demand side, for about 20 years, the total power demand in the US has been flat. Correct. No growth, 0.3% growth. But in the next 20 years, it's expected to grow 50%. And about a third of that is going to come from data centers. And to meet the demand, you essentially need to leverage all kinds of power that's available. Like I said, it's gas, it's nuclear. We have an SMR that's coming online in 2029 in Ontario. Our first SMR application at TVA went in this year. So there is significant growth in nuclear that's coming up. From a gas perspective, depending on the gas turbine, sometimes heavy duty is the answer. Sometimes it's your aeroderivatives. Sometimes it's, you know, different types of turbines. And also future-proofing some of these gas turbines so that they can run on hydrogen in the future. So gas is a fantastic bridge right now. So electrify now, decarbonize later. So I think that's something we can do as well. And we are also looking at, you know, wind and solar. So all of them belong in the energy equation. And I think that's what we're working on. It's what the market needs. Energy abundance is what we're chasing here. And energy abundance is really an all of the above kind of answer right now.
Right. You know, Chase, you guys have been at the forefront of what Jensen talks about, extreme co-design. Right? Moore's law is dead. The data center is now the unit of compute. This is about power in and tokens out. Crusoe is building some of the most capable data centers in the world, in Abilene and other places, in partnership with NVIDIA. Talk to us a little bit about what you see happening in that world of extreme co-design and why you've been so successful, along with companies like CoreWeave, in pushing the frontier on how NVIDIA brings its chips to market.
Absolutely. So, you know, Crusoe is an AI factory business. And the thing about AI factories is this incredible composition of all of the greatest industries humanity's ever produced, from everything the gentleman next to me are working on to, from a cooling, a power generation, a storage perspective, all the way to, everything that we've done in the silicon space, and, most importantly, our partner with NVIDIA, our partnership with NVIDIA. But this process of taking electrons and turning them into tokens is just one of humanity's greatest opportunities and challenges over the next decade. We see it as just a very complex challenge in terms of just the scope and magnitude of these investments, and it's requiring just an incredible amount of resources across the entire economy.
So tell me a little bit, I mean, again, I'm out of my league, out of my depth a little bit here, but the 800-volt data center, kind of architecture that I know NVIDIA has been pushing as just one example of this, extreme co-design. What are the things that you see happening and coming down the pipeline that's going to drive that equation in terms of power in and tokens out?
Yeah, so, I think the 800-volt rack design is like a great example of us, thinking through from a first principle basis, like, okay, data centers are sort of built in this way, and that's how we built them 25 years ago. Is that really how we should be doing it today at the scale of gigawatts? Maybe not. When we think about this data center scale computer, where it's not just a single server, it's not just a single rack, it's really the entire system working together as one cohesive unit that's thinking as one giant brain. And how do you think about that from a networking perspective? How do you think about that from a cooling perspective? How do you think about that from a, from a like entire system perspective?
Yeah.
And the power aspect of that, you get massive efficiencies from doing things like changing from 48 volt to 800 volt. Like that's like a huge efficiency gain that like all of us would benefit from. And so it's just one example of like this cohesive, collective, industry-wide partnership that's required to bring this infrastructure to life.
And if I can reinforce 100%, this 800 volt is an example of how you can make the whole system not only just more energy efficient, but really scoop up kind of a power that is available because the system can be redesigned from scratch. Again, you were talking about the system, think system, not just components. We've come from decades of data center being built a component at a time. I was talking about an inflection point in the way we think about data centers. This is a fantastic example. There are many examples. Again, we have to think the powertrain, the thermal chain, the whole prefabrication as ways to industrialize the way we build data centers like we've never done before. So believe the next 10 years, the next 5 years, 3 years will be very different in that respect than have been so far. We've seen some picture of what we call Vertiv One Core. That is exactly that type of modularization, system level, all parts integrally designed to work together. And that is perfectly applicable to the 800 volt powertrain. So things are changing fast.
So China is building faster, they're building bigger. You had mentioned the 10x on nukes to our 0 or 1 if you count Georgia. And we're behind. I mean, I did China, I worked with China in 1995 and on buying sheet metal and plastic injection molding. And they sent me, I said, hey, send me a picture of the site. And the picture had no roads, had no electricity. And I said, well, how are we going to be up and running in 60 days? And they said, watch. And it happened. And China was willing to do whatever it took to build infrastructure. And here we are 30 years later, and it has continued. What is it that we could do to go faster? I was at I think we were both at the winning of the AI race here in DC. Chase, you were here as well on stage. What can Washington do to get this moving faster? Start with you.
Well, look, when you see what happened in the past months, it's been very clear for the local government that AI has been big on the agenda and energy has been big on the agenda. And the two are really interconnected. So I think what they are doing right now to make sure, and it's a bit what my colleagues have said, it will take an ecosystem at the end of the day. And you might not be aware, but whether it's NVIDIA, us, the four of us, you have more and more an ecosystem of people who are working together to support the local government to make it happen. We are working very closely also with all the hyperscalers. And what is very, very important at the end of the day, and Joe talked about it, we are living a huge revolution in our sector. You know, I've been 32 years at Schneider Electric. I think more has happened in the past 2 years than in the past 32. So the fact that you have this ecosystem which is working together, working closely with the government, I think we have the good discussion, the real discussion on what does it take to make it happen. And we are moving very, very fast. US, by the way, when it comes to AI and data center, is still by far #1 in the world today.
Yeah, President Trump signed an executive order which basically said removing some of the barriers to that. Are you currently experiencing that?
Yep. Yeah, but we're working on all of that for sure.
Good.
I mean, that's, you nailed it. I mean, Secretary Wright and Secretary Bergrum, every time I've seen them, heard them, when we're in DC, they're actually asking us, what is your recommendation? How do we go faster? What do we need to do? I think it's a complete change in kind of the mindset because now it's been elevated to a national security issue.
That's right.
Right? This is no longer just about economic security. It's about national security and consequently moving, faster than ever. Which brings me to this question of where can startups help? Right? When you think about, we're sitting here with some of the largest industrial companies, in the ecosystem. What, if anything, do you see happening out there in the startup ecosystem in Silicon Valley, in power generation, certainly, obviously, Crusoe and, and the work of CoreWeave and others, Nebius, in terms of building out these new data centers has been critical. But anything else that you see as interesting that people in the crowd might want to pay attention to?
Absolutely. So if you look at, I think startups are the lifeblood of our innovation ecosystem.
You're here.
And when you look at what we're doing, I mean, GE Vernova is 18 months old, spun off as an independent company. And our CEO intentionally headquartered it in Cambridge, Massachusetts, because of the innovation ecosystem with MIT and the universities and everything surrounding there. And we are investors in a lot of these startups, but startups are bringing, so when I look, let's go to the grid, for example. Our grid was designed for, 50 years ago, relatively stable spinning loads, spinning sources of power, relatively stable loads. It's a completely different world right now with the AI workloads, hundreds of megawatts in milliseconds. And then on the source side, you have wind and solar, where these resources, they're changing constantly, they're fluctuating. So having a grid that can actually deal with this is really, really important. So we are working it, all our competitors are working it, but the startups have a really, really important role to play there. There's the hardware aspect of it and also the software aspect of it. When it comes to hardware, we have power electronics, innovative solutions. I've seen companies that are cooling the transmission cables. I mean, just fascinating stuff, so that you can increase the capacity to transmit power. But how do we leverage power electronics, StatComs, fax solutions, to make sure we can leverage the infrastructure more? Startups are playing a huge role out there. And they're also playing a very massive role in the software ecosystem. How do we how do we predict, what's going to happen? How do we make sure the right resources are there at the right time, at the right place? And how do we manage in real time from millisecond scale to minutes and hour scale? How do we dynamically manage the grid across the country? These are all big, challenging problems. We are working it, but a lot of the innovation in that space is coming from startups. So we're seeing, again, I don't want to name a specific startup, but we're seeing lots of innovation coming from there. So I'm really excited to work with the startups and see how we can kind of, accelerate this transition.
And maybe the same question for the two of you.
Yeah, maybe if I can, one point, if I come back to what I said before, AI depends on compute depends on energy, and actually energy depends on energy intelligence. What I mean by that, at the end of the day, it's about data. You know, even if we are Schneider Electric historically more a hardware company, actually today we are more an hardware and in the digital company. And back to your question, what we love to do with startups, the more you have startups which are coming on this data intelligence and looking at the different assets you can have in the AI factory, because it's a very complex one.
Yes.
You will have switchgear, you will have racks. We are doing a lot of R&D, but the more they are taking those user cases on how you can make it more efficient, how you can capture the data, we are helping to structure the data, we are helping to create an ecosystem, but our customers are asking for even more. So the more you have startups coming in our own ecosystem, which is completely open, by the way, not protected, the more we deliver solutions and the more we can accelerate energy intelligence in our industry. So we love having those startups taking a strong interest. We need more and more smart people and capital, you know, coming from all of those startups.
Yep, absolutely, 100%. And if I look at it from the infrastructure technology, now the industry, infrastructure, data center, infrastructure technology has been static for many years, and then it started to accelerate crazy in the last 3-5 years, and it is going to accelerate more. When you have this kind of acceleration, people like us that scale. I mean, scale is absolutely essential, but you cannot just scale in this market. You have to be an innovator and scale. Innovation happens organically. Innovation happens inorganically. There needs to be a base of startups, inventors, creative minds, engineers out there that define what the new technology will be, because the new technology cannot be just nurtured within the Givanova, Schneider, or Vertiv.
Yeah.
It needs to come also from spring, from the, let's say, entrepreneurial fabric of a country. And that the two things combined and scale. And that's what we see very auspicious times for right now.
Chase, where are the most exciting areas you see innovation? When you look ahead 2-3 years, you say, I can't wait to bring this into, right, the AI factory.
Yeah, you know, just adding to this sense of urgency, and I think this huge opportunity for startups is, you know, just this sense of, you know, startups have, you know, the benefit of being able to move very, very quickly. And, you know, we're at a moment of just incredible urgency across the world in terms of bringing this infrastructure to life. You know, I think to your question around things that, you know, we're really, really excited about, you know, what's changing in the data center is, you know, it's unbelievable how much change is happening over such a short period of time. You know, from, you know, the cooling architectures to the power densities of the systems. You know, I think if you look 20 years ago, a single rack in a data center might have been 2 to 4 kilowatts. You know, today with the, you know, GB200s, you know, you're looking at 130-ish, 140 kilowatts, depending on peak demand. You know, and then you play it forward and you look at, you know, Vera Rubin, you look at Feynman, these are, you know, 1 megawatt racks, right? You know, this is 1,000 homes worth of power in a single rack in a data center. That requires tremendous innovation across, you know, the cooling systems, the network systems in terms of cabling these things together, which we're seeing, you know, a lot of tremendous innovation. You know, I think there's a lot to be said about just like the overall memory optimization in the systems. Like, you know, one thing Crusoe is very focused on is not just the hardware aspect of bringing these AI factories to life, but actually the software aspects of actually how do you operate the AI factory to produce intelligence very, very efficiently. Right. That requires getting data and moving data from, you know, things like, you know, your object storage, you know, bigger storage platform to directly into HBM, and how do you do that, you know, ultra efficiently. And we're really excited about some of the innovations taking place across the networking stack and the overall software innovations that are, you know, bringing data to compute way more efficiently, so we can actually utilize the GPUs and get the most intelligence per unit of investment in compute.
You know, it may be appropriate because we're here at GTC. NVIDIA has been an active investor across the space. They're forward engineering, working with partners like you guys to help drive this, you know, this extreme co-design in the data center to get us the benefits of Moore's Law now that Moore's Law is dead, or even more. Can each of you just give us an example of, some of the things you're doing with NVIDIA in particular that are helping to drive this flywheel of innovation, and how this unique partnership might be accelerating the path that we're on?
Yeah, I can maybe.
Please go to.
We can start exactly. We were talking about the 800-volt DC as an example, and that's an area where we are actively working together.
Yeah.
So how will we make that technology available? And what we have to do as infrastructure provider, we have to make that infrastructure ready ahead of the GPUs, the silicon that will land, because that infrastructure needs to be in place. So that's an area. Another area of great importance, still continue to evolve, is everything around liquid cooling. Let's not forget the transition that has occurred and is still occurring in the industry from air cooled to a liquid cool, and it's a colossal change, if you will. There's still air, it's a mix, it's a hybrid, but more and more loads are liquid cooled. So all these things require technology partners that are ahead of the pack, and then the industry can follow. But we have to pave those ways together.
Yeah, we have a ton of deep partnerships with NVIDIA across the stack, and it's so amazing that this company just spans so many aspects of the economy, from power generation to the most cutting edge artificial intelligence development. But we're working with NVIDIA very tightly on AI factory reference design. So how do you actually build these gigawatt scale data centers and do it efficiently from a power generation, from a cooling, from a power perspective. And so that's one big aspect that we're investing a lot of time with NVIDIA. Another is on the software layer, right? So working with them on what the things like Lepton, which is basically a distribution of getting compute in people's hands so that they can run their workloads very efficiently across various neocloud partners like ourselves, as well as things like Dynamo, which is basically accelerating inference and creating how do you actually get more utilization, and a lot of these memory optimizations that Crusoe is focused on pushing and innovating on, so that people actually get more tokens per unit of compute from their systems.
Let me just interrupt by asking, do you see any other chip company out innovating? Right, there are a lot of other chip companies. You guys work with other ones, but NVIDIA seems to be playing a really unique role in pushing the ecosystem forward. Maybe a little commentary on how it's similar or different than others.
Yeah, the thing I would say about NVIDIA that they've done so incredibly well, and kudos to Jensen, is just the ecosystem itself, right?
Exactly.
NVIDIA, I forget the exact head count, it's 35,000 people-ish, something like that. The amount of leverage that they're able to get from those 35,000 people, and then the ecosystem of builders is absolutely incredible. And that's, that's kudos to Jensen in terms of, building out all these different work streams and workflows across energy, data center design, all these different SDKs that they've released that have just helped unlock this collective intelligence of society and the startup ecosystem to big enterprises.
Just to kind of build on that a little bit. By the time you're done with all four of us, maybe you'll get a view of the scope and breadth of the ecosystem that NVIDIA is playing. We talked about software, optimization, AI, we talked about cooling, we talked about 800-volt rack. We are more on the power generation and grid side. So we just released a white paper with NVIDIA. We're working with NVIDIA on reference architectures for power gen inside and how do you manage it. So we just talked about the grid a few minutes ago, how complex it is, different source of power, load balancing, and so on. Now, the power is not available today at the grid sometimes when folks like you are building the data centers. So there's behind-the-meter power, there's bridging power, but when you do that, you're dealing with all the complexities of the grid inside the data center. So how do you design and architect it so that you you can actually manage the power flow with battery energy storage, with power electronics, fax, all kinds of different systems, working with people who were in the medium voltage and low voltage space that my colleagues here are doing. So it's an ecosystem where all the way from the power gen to memory to algorithms, cooling, and the entire thing, we're all working with NVIDIA. So to me, it's amazing to see how they're curating the entire ecosystem and moving us all forward, helping us move forward.
And maybe we'll end with the, Schneider's commentary on this. I don't see anything else out there that has this level of systems thinking, right? It's extraordinary, the breadth. It gives me a lot of encouragement about the gains yet to come in terms of America's reindustrialization around power and AI, generation. But how is Schneider working with NVIDIA to drive this forward?
Well, look, a lot has been said, but for me, what is very unique in the vision of Jensen is, first of all, to work with partners. What we love with the NVIDIA team, they share a lot with us. They speak about the Omniverse, they speak about the next generation of chips, next generation of GPU. And when you can work as a technology partner upfront and in a very open manner, that changes the game. What I would say also, Jensen has this famous sentence about the speed of light. He's forcing the entire industry, but in a very positive way, to work at a very different speed. And for us, for Schneider Electric, I can tell you, it has changed a lot of stuff in the way we are managing the company. Joe mentioned the shift from air cooling to liquid cooling. We discovered that by working. We knew it would come.
Yes.
The question was when. We discovered 2 to 3 years ago that it could come much faster than expected. But if you ask me today, what does it change? We have to completely rethink the way we design those data centers. And I like what Chase mentioned in his sentence. He said design, he talked about maintenance, he talked about operation. So you have to completely rethink the way you build those AI factories from the design stage, to the build stage, to the operate, to the maintenance. So it's about building a digital twin, and what Jensen and the NVIDIA team are forcing us to do is to think about those next generation, and guess what? Software is playing a big role, and software is powered by AI. So again, it's a loop on which we are working all together.
One thing I want to touch on, follow up there, just in terms of the system-wide innovation needed to invent solutions to support this infrastructure at scale. One of the conversations I was having backstage with Olivier and is just around this notion of how the utilization of the data center scale computer impacts the power swings, because you have this massive, large variance in terms of, like, when you have a gigawatt scale data center that's operating as a single brain, you have this problem where it's pushing data to the GPUs. All of the GPUs are running their back propagation or their compute, their matrix multiplications, and then they're publishing the results to every other GPU on the cluster. And when you have that, you actually have these massive power swings that, it's like, whatever, 6 hertz, somewhere in that range, where it's, you have these massive load oscillations. And that creates a lot of problems for utilities and on-site power generation. Like, GE Vernova doesn't like it when we have these massive power swings in the actual power utilization of the turbines. So it's actually created this system-wide partnership where we need to work with our on-site generation, we need to work with the utilities, and most importantly, we need to work with folks like Schneider to innovate these solutions where we can actually create a buffer through battery systems that can absorb a lot of this load oscillation that we're seeing from these large-scale training workloads and these system-wide workloads that are running on these massive scale computers.
I mean, one of the things that blows me away, if we think about the Manhattan Project, that cost about $4 billion over 4 years, right? Inflation adjusts that's about $40 billion. As a percentage of GDP, it was 1% of GDP, so let's call it $400 billion. Jensen has said we're going to spend $4 trillion over the next 5 years. So private industry is going to spend 10x what we spent on the Manhattan Project. And just listening to the decentralized coordination, really where NVIDIA plays this role in pulling everybody together and pushing everybody forward, it reminds me, like, the speed of that is very commensurate with what we think about the speed of, the Manhattan Project. I don't see it happening anywhere else in the world. I think that all of your companies are critical to the success, of the American AI race. And it's great to have NVIDIA helping push it all forward. I know we got to jump, so I'm going to throw it to you, Patrick.
No, that was a great ending. Gentlemen, I just want to thank you so much for coming up here. And I hope everybody out there listening has a better understanding of the challenge that is ahead of us. And also, Washington can hopefully clear as many roadblocks as possible to let all of you cook. Thank you very much.
Thank you.
So let's go back down to CNBC's Kristina Partsinevelos on the floor.
Thanks, guys. You're right. This is all about the build out, $4 trillion that Jensen has spoken about, and we're hoping that we will get more details about just that evolution. The crowd here is quite impressive. Many of these guys are just waiting in line to take photos. I didn't expect people to actually wait to get into the building right before 8:30, but they were here. And like all GTC events, considering this is number 4 this year, they've got a merch truck, which I'm curious, is it expensive? Sir, do you think it's expensive?
No, it's just the perfect price.
What are you buying?
A lot of gear for my kids and a little bit for myself, some socks, shirts.
Do your kids understand what NVIDIA does?
Not yet, but they will.
They will, they will. Thanks, sir, thanks, sir. You know, it's kind of funny. We have a lot of tech people here, policy leaders, I saw members of the military as well. But one of the perks for a lot of investors that here is just the stock climb for NVIDIA. No joke, last night, a man at the Marriott, I was just getting some tea and cookies, and he decided to show me his portfolio and how much he's made on NVIDIA shares, which, by the way, have climbed 1,400% just in the last year. Market cap right now is about $4.6 trillion. Pat and I were talking backstage, that 5 trillion is just around the corner. We'll see about 6 trillion. But back to why we're here today. GTC event in DC, the 4th one. Here's the, I guess, black carpet that we're going to go roll upon. Oh, don't worry, you can be on camera too. A lot of people are expecting more news about the quantum collaborations with NVIDIA alongside public partnerships. We spoke to Coatue CEO too, just about the depreciation cycle often comes to mind for a lot of investors, but he's saying that they've been sold out of A100s, H100s, H200s, everything. So maybe this narrative doesn't hold true. We'll let the audience be the judge of that. And speaking of the audience, look at these. Look at these guys. You've been sitting here since what, 9 a.m., all of you? And you didn't have to do anything special to get these seats, right? You just signed. Run. That's actually a great answer. The crowd is packed, which is to be expected, right? From GTC in San Jose, you could barely get a cab. I had to jump out of my cab and walk because it was so crowded with people here. You, ma'am, what brings you here today?
I'm just here listening into all the NVIDIA stuff. I work for Department of Defense, and so just listening into, what innovation is bringing from all different industry partners.
And anything that stood out to you thus far from any of the panels?
Absolutely. So everything that I heard from Martin on the guardrailing of AI and policy type of stuff, to obviously infrastructure and how industry, government needs to work together to enable a lot of that. So absolutely.
Thank you. Thank you very much. I put you on the spot. We didn't test this at all. One of the interesting things that we look at from, I guess, an investor perspective is just the return on NVIDIA shares, because leading into GTC, often after, let's say, the big GTC, the developer one in San Jose, there tends to be a nice little stock pop. On Friday, I was just checking out, there was quite a bit of options activity, which would, lead maybe some people to believe that we expect some big news today, and that could move markets. That's why we're here. And I do think the significance of being in DC cannot be overlooked, right? A lot of this is about changing the dynamics here, really building out power infrastructure. We know that that's going to be a major, major roadblock here in the United States. And I'm trying to show you, chat it up, provide some insight while we're going through the crowd over here. You guys, are you NVIDIA employees? No. Tell me, what brought you here today?
We're just trying to network and meet people and learn more about AI.
And so this is, I guess, new to you then. What have you learned thus far then in regards to AI?
There's a lot going on with it.
Okay. That's an honest answer, true, because it is very complicated, especially when you start speaking about acronyms and stuff like that. And we'll just keep going through the crowd right now before I get to my next guest. So my purpose is not only to give you an inside scoop as to what's going on here on the floor, but then also we're doing some CEO interviews, hopefully getting some more insight as to not only their collaborations with NVIDIA, but more so how we move forward. Because right now there's a lot of big topics, the AI bubble narrative, whether that is the case despite all the hyperscalers being able to use their free cash flow to spend. The other narrative, which unfortunately is popular well, not popular, I should say, but relevant right now, is just the efficiencies from AI, which is great, but then what does that mean for job displacement? So another major narrative. And then lastly, of course, power, which keeps coming up today. I know we have more panelists that are going to be speaking about the power infrastructure. I'm getting people like mid-bite. He's smiling because he knows he's on camera. Sir, you look important because you have a pin. What do you think so far of this event?
I definitely think it's very interesting. I didn't know a lot about AI before I got here. Some of the concerns that have brought up were things that, just I've heard off like the news and stuff. So it's good to hear it from like the experts.
And are you from, what department do you work in?
I work with the Marine Corps over at the Pentagon. Yeah.
And so do you feel like this is a little bit different? You have tech and policy leaders, the Marine Corps, just more the DC-like people just merging together here. Is that something that's new and you guys are talking about it back in your office or anything?
Yeah, we're trying to see how we can leverage AI to make our processes a lot faster and more efficient so we can get after what it's, our main job, which is defending the country.
Awesome. All right, thank you. I know I'm putting a lot of people on the spot, and not everybody really enjoys doing that, so you did a great job. Thank you. And you know what's great here is that you do have a lot of really advanced people in terms of technology. They can talk about, putting atoms in steady state and how that works, and then others that are just learning about it for the first time. Why? Because that's what GTC does. It brings all sorts of people here together to not only mingle, listen to the CEOs, hopefully catch a glimpse of the superstar of the day, which maybe we should start taking bets on Polymarket, which leather jacket he will be wearing, or maybe a t-shirt. I don't know. I know a lot of us didn't want to wear leather jackets, right? You're not wearing one. I'm not seeing any leather here, so perhaps that's done on purpose. But we are going to head over now to Brett. Brett has been waiting patiently for me from Figure AI. You are the CEO. We had, just in this audience now, we had a lot of people that are new to AI. And let's start with what you do, humanoids, because I feel like to a lot, what is that? What does that even mean?
Okay, so Figure designs and manufactures humanoid robots. Humanoids are like mechanical humans. We have hands, legs, head, sensors, cameras, onboard GPU for AI processing, and the goal is to be able to do human-like work in the real world. Just go out and do commercial work, manufacturing, logistics, warehousing, and be able to put robots in the home to do cooking, cleaning, dishes, laundry, all this. Basically any activity a human does in the physical world.
And you are an example of a success story because I think your company is, 3.5 years old? You have 400 employees just within that short time span. And I was looking at the valuation. You went from, what is it, 2.9, or maybe I have here 2.6 billion dollars, all the way up to 39. What justifies that leap in valuation? What milestones have you hit just in the past year?
Yeah, it's a good question. I think the story here is that if we can create mechanical or synthetic humans, it'll create the largest economy in the world by a long shot. Like little under half of GDP is human labor. Figure's probably made about 5 years of progress in the last 12 months. We have robots out now commercially running every single day. We have a robot right now running commercially in a manufacturing commercial partner of ours. And we have robots that can do end-to-end activities, let's say fold laundry, do dishes, only with neural nets. So I think what's happening is we're approaching this kind of singularity point for humanoid robots where it's, in the coming years, we're going to see humanoids out in the real world, I think at scale, that are doing end-to-end useful work for humans.
Which brings me back to that topical point I brought up, job losses due to AI efficiencies. And you're talking about somebody doing my dishes or working on the manufacturing floor. Is that just an inevitable, outcome of this AI revolution that obviously people are going to be displaced, much to the dismay of many listening right now? I'm not trying to take that.
Do you like doing dishes and laundry?
No, but I like having my job, right? And you see journalists on that list that could potentially be taken over by some type of AI bot or deep fake, et cetera. So how do you mitigate that?
My view is we've been in this automation exponential for like the last couple centuries, and AI is just like largely a progression of computation that we've seen the last few decades, where more and more automation is taking place around the world. And this is happening both in the digital world. We'll have more and more agents doing work like humans, and like the humanoid is like just manifestation of a physical agent, being able to do human-like work in the physical world.
And you know what is such great timing? We're talking about humanoids, we're talking about the collaboration with NVIDIA, and why not just ask the leader of NVIDIA himself to just share some insights.
Good to see you. Thanks for having me. Yeah, good to see you.
So we were actually talking about job displacement. Well, we were talking about AI and the concern right now about job displacement, and I know that you are
What's
involved.
everybody doing here?
Watching you at the moment, that's for sure, and us, right? Could you just speak to maybe the evolution right now with AI? And
I want to be on TV with Brad.
I'm gonna get to why we're in DC in a second, but I just wanted to get your insights on the concerns about the job force and what AI efficiencies would mean for the job force, especially right now, given some jobs are starting to be spread thin.
We have labor shortages all over the world. If we had more workers, companies would make more money. If we were more productive, companies would make more money. When we make more money, we invest more money so that we hire more people. And so it's very likely that the companies that use AI first, that use robotics technology first, will be the most successful first, and they will end up hiring more people. You're going to lose your jobs not to somebody, not to a robot. You're going to lose your jobs to somebody who uses a robot. You're going to lose your jobs to somebody who uses AI. And so if you look at NVIDIA today, 100% of our software engineers use Cursor, 100%. And we're hiring faster than ever because we're creating more chips than ever, we're developing more software than ever, we're more productive than ever, and it looks like the company's growing faster than ever. So there's a lot of great things that goes along with being productive. Nobody ever says, you know what we want? I want a company to be less productive. I've never heard that before. I've never heard somebody who well, if you look at companies around the world, about, 70% of the companies in the world feel they're labor short, and that they have a hard time hanging on to employees. And so robotics is going to really help that. But here's the thing. I think, Brett, you're onto something huge. This is likely the next giant consumer electronics market. And so I think he's onto something.
I love that, Brett, you're helping me with my job. See, I'm going to be displaced.
I'm here to watch him. Are you kidding me?
Can you speak about the significance of being here?
Brett just closed a round.
Yeah, we talked about it.
Figure is worth, what, $40 billion today?
Yeah, close.
29, was it? Or 30?
39.
$39 billion. You're here. That is impressive, and congratulations. We did talk about that giant leap.
You're a whopping 3-year-old company.
3.5.
Yeah, well, that extra half really made a difference. Incredible.
Which is a great example.
3 years after I founded NVIDIA, NVIDIA was worth still precisely $0 billion. Yeah.
Perplexity, I was speaking to the Perplexity CEO, same thing. Just a few years, 300 employees, valuation in the billions too,
Aravind's doing great.
Which is a success story with AI. Could you speak to the significance about being here in DC? Because this is the 4th GTC. It's a different groups of people. I met some people from the military, some that have never really, they don't understand the interconnects of AI, quantum, forget it. Can you speak to why we're here?
The technology industry's really changed. You know, Brett, when I first started the company, quite frankly, nobody cared about technology companies, to be honest. And we're startups in Silicon Valley doing our thing. But today, technology is at the forefront of almost every single geopolitical conversation. Technology is obviously one of the most important industries in the world. And what I can say is that on behalf of, and both Brett and I, have the benefit of serving and being part of the American technology industry, that I would say is our national treasure. This is our single most valuable industry, unquestionably one of the most important industries in the world, and we're really proud to be part of it. And so, anyhow,
what would you
we're here.
Yeah.
Make sure that Washington D.C. has a front row seat of what NVIDIA is working on. and what NVIDIA is going to be working on. And so this is GTC, bringing GTC to DC is really exciting for us. You know, doing GTC at our nation's capital. Yeah, it's incredible.
What do you think are the major roadblocks? Power has come up a lot in the conversation, and it seems like we do have a lot of headlines building out X gigawatts, but the capacity to build that infrastructure is a roadblock, essentially. So what do you say to that maybe these promises can't come to fruition in the near term?
Cash flow matters, power matters, land power and shell matters, power generator matters. These are all things, factories matter. These are all things that Brad and I think about all the time. And his business, my business, is really very similar. But it comes down to one thing and one thing only: profitable token generation. The moment we have intelligence that's worthy of being paid for, and as soon as that flywheel goes, then everything else will take care of itself. And this is no different than the moment that humanoid robotics starts to do productive things and people are willing to pay for it, and it's a profitable endeavor, then you could scale up as large as you want to scale up. This is no different than when TSMC in the old days manufactured the first profitable wafer. The moment that happened, they could build up the factories as large as they want. And so that's really the moment we're looking for. We're looking for that virtuous cycle where AI starts to generate productive tokens, profitable tokens. After that, the flywheel takes off.
An executive at another company told me that tokenization, or just profits per token, could be the next oil, and for countries all around the globe really focusing on that output. Do you kind of agree with that, just in terms of tokens? And maybe explain too to our audience, because not everybody here is as advanced.
Computers speak numbers. Tokens are numbers. Tokenization, we tokenize almost everything. We tokenize images, words. Brett tokenizes motion. You know, a sequence of plans that a robot performs. And so everything that we can tokenize, AI can understand. So if we can tokenize proteins, if we can tokenize chemicals, we can tokenize motions, what action and behavior, all these things that Brett is trying to tokenize. We tokenize video, we tokenize 3D, everything, we tokenize fluid dynamics. We tokenize anything we can tokenize, AI can understand. And everything that AI can understand, it can translate, it can generate. And so that is the revolution that we're in, and that's why token is at the core of everything that we do. And ultimately, what we fundamentally do is to transform electricity into tokens, and that's what an AI factory does.
We come full circle. I've been told that you have to keep going, so we keep the show on because you have a keynote, which is very soon. Yeah, an hour and 15. Jensen, thank you so much. We'll see you soon. So we'll actually continue this conversation because we did interrupt a little bit, and now you've got a massive crowd to watch you, so no pressure. If we could, I want to reiterate the fact that 3.5 years, 400 employees, and you have done incredibly well. One of your customers is BMW. Can you just speak to maybe just, this is the last question just because of timing, just the relationships, any other customers that you might be announcing soon, please?
Yeah, we basically, we have a few customers now that we're in commercial discussions with. The goal is, like, we're looking for ability this year and next to deploy robots into the real world, run them every day, make sure we get useful performance out of them, make sure we get ROI out of the robots, make sure we can bring humanoid robots into real life.
ROI is a big topic, but we have to end it there because that seems to be something a lot of people are concerned about. But $39 billion, congrats on that. And we'll send it back over to you guys. Thanks, Brett.
What a great surprise with Jensen coming in. Kristina, thank you so much. You're doing great out there. So science used to move at the speed of experiment. Now it moves at the speed of compute, crunching data as fast as we can collect it, modeling everything from the atom to the atmosphere. Then this just speeds up outcomes.
No doubt. And as AI begins to supercharge quantum computing, we're on the verge of discoveries that could redefine physics, chemistry, and life itself. Here's how accelerated computing is unlocking the next frontier of human discovery.
We're going to take a giant step up in several areas, in high-performance computing for scientific computing, as well as quantum classical computing. quantum computing is reaching an inflection point. We dedicate ourselves to creating accelerated computing stacks to enable quantum computers. Now we could simulate data using a quantum computer and use that as ground truth to then go train an AI model, amplify the capability of AI to be able to solve the drug discovery, the material sciences, the biology applications. It is clear now we are within reach of being able to apply quantum classical computing in areas that can solve some interesting problems in the coming years. This is a really exciting time.
Quantum computing is at the heart of the fastest acceleration that should unlock scientific discoveries. From molecules to the cosmos, AI is transforming how science models the world. And leading this conversation, we have George Church, Chief Scientist at Lilly Sciences, Matt Kinsella, CEO at Inflection, Mark Tessier-Lavigne, co-founder, chairman, and CEO of Zyra Therapeutics, and Anirudh Devgan, president and CEO of Cadence. All right, Matt, let's start with you here.
Okay.
Big day, big quantum day. Can you talk about how the mixture of, we'll call it classical computing and quantum computing is really going to change the game?
Yes, I can talk about that.
Well, that's an easy one.
First of all, first of all, thanks for having us. This is going to be a blast, guys. This is going to be a lot of fun. When we say quantum, maybe we should just define some terms, because not everyone in the audience might know what that means. And so when we say quantum, we're talking about the world of the very small, the atomic and the subatomic levels. And there's a whole different set of rules that govern the day down there called quantum mechanics. And so when someone says quantum, it's taking advantage of those very strange quantum mechanical properties.
What?
Hi.
What's going on here?
Jensen Huang, everyone. Oh, he brought us water.
Thank
That's
you.
what he does.
Yes, we do.
Thank you. It's very important to stay hydrated.
What is this mumbo jumbo about quantum? Superposition,
Entanglement.
entangling stuff. Like, this is just mumbo jumbo.
Hey,
Mark,
good to see you.
Jensen, I brought you something.
Yeah.
You know, once a busboy, always a busboy.
Yeah.
From Denny's to
Thank
DC.
you.
From Denny's to DC.
Yeah. Thanks for having us.
It's incredible. It's been an amazing morning. And this panel, I think, saving the best for last, Jensen. So, maybe ask this. You caused a kerfuffle last year when you made some comments about quantum. Anything you would like to revise, as we're about ready to launch our quantum panel here, about how NVIDIA thinks about quantum?
I gotta tell you, I'm afraid to say a word. If I just said quantum, the stock price goes up. Quantum, quantum, quantum.
Buy.
Here, listen. The work that we're doing together is really important, obviously, and I think the message that what I was trying to say is that quantum and classical computing really needs to work together so that we could bring in the usefulness of quantum computing. And it's becoming very clear that the two industries really need to work together as one. And that quantum classical computing, quantum GPU computing could really help solve a lot of very sticky problems, very challenging problems associated with quantum computing. And the ecosystem and ourselves, we're doing some amazing work. It remains incredibly hard. I mean, the work you guys do, it's deep science. We do deep engineering, they do deep science. And so I'm excited about the work that we're doing together. I won't ruin it by telling you guys what it is, but this doesn't work.
Now it does.
Yeah.
Now it does.
It's okay. No, this is about you guys. This is about you guys. And apparently, I want to thank everybody for coming to GTC in Washington, D.C. Yeah. So the original plan, I'll be honest. The original plan was President Trump was going to be in Washington, D.C. And so we brought GTC to Washington, D.C. The administration's all going to be here. And then literally 2 days ago, President Trump said, Jensen, could you be in Korea today? And I said, I would love to be in Korea today, but I came to visit you in D.C. And so anyways, we're in two sides of the world. But anyhow, he wishes all of you well. He's going to see me in a day, and we're gonna go and support the president in his tour through Asia. You know, he's our president. We want him to be enormously successful so that America could win and America could win around the world. And so anyways, I want to thank everybody who's here working in D.C. Thank you for your service, and thank you for coming to GTC. All right, great to see you.
Thank you, Jensen. Take care.
We can't wait to hear more. I mean, we said last night, we are in Washington. We've heard on the panels this morning, so maybe we'll just jump to this, and then we'll come back, Matt, to that.
Yeah.
But, you know, there's an extreme need to accelerate AI. I think Jensen's been at the forefront, NVIDIA leading the charge with the president, the White House, and Capitol Hill. But we also see a lot of doomerism. You know, you guys are in what I would call long haul, you know, investigation, discovery, and execution. Talk to us a little bit about the importance of having Jensen leading the charge and NVIDIA leading the charge to your businesses that require decades of innovation, and maybe how you're partnering with NVIDIA to make that happen. Matt, we'll come back to you on that.
Absolutely. Well, I mean, we have looked to NVIDIA as a trailblazer of how you bring deep tech out into the market in a staged, commercialized way. And so as we've thought about bringing quantum technologies out into the market, we saw them point their GPU engine at graphics to start, and then at crypto mining, and they always found the next thing until the crown jewel of large language models came around for them. And so the way we've thought about commercializing quantum is by pointing quantum at areas where there is true quantum advantage already, like timekeeping, and then quantum RF sensors and antennas, and on the trip to that crown jewel of quantum computing that will do things that classical computers can't do. And so we've really used them as what we've modeled our strategy against. And so Jensen's led the way in many ways, and including one of them is how to commercialize deep tech.
Right. Absolutely. Do you have any comments on this, George?
Well, I totally agree. I think that another early stage thing that we can do that roughly involves quantum is natural computing, where the best simulation of a particular system is the system itself. It's 100% accurate, and there's certain systems where we have the synthetic ability to make them even more cheaply than we can compute. But they're definitely quantum. They're very complex systems are possible.
For sure. So Anirudh, you could have been on any one of these panels, all five, given how broad your company operates in. But I do want to ask you about how is AI accelerating all the way going from the chip to the entire system, and as we heard from our panelists before you, also into electrical and cooling systems and the power grid.
Yeah, first of all, great to be here. And so for people who are not familiar with Cadence, Cadence basically makes products to design chips and electronic systems. And we have a long history of working with NVIDIA. We have worked with NVIDIA for more than 20 years. And it's remarkable to see, what NVIDIA has become and, under Jensen's and what it will be going forward. Now, I think the key thing for chip design and also now chip and systems are merging together is there's a lot of deep science in it. So basically our products are software products, which is a combination of CS plus math plus physics, okay, and applied to chip design and system design. And the whole stack needs to be optimized. And what AI can do is it can provide the next level of innovation, the next 10x productivity improvement, because chip design itself is exponential. So if you look at chips now, by 2030, the chips will be 10 times bigger. The systems will be 30, 40 times more complex. So we need the next level of productivity improvement that AI automation can provide. So to me, it's a combination of AI, the basic science, the ground truth, and accelerated compute. This is what I've called for a while the three-layer cake, and all three layers of the cake have to work together with AI, the ground truth, that's still very important, and then accelerated computing. And the interesting thing with accelerated computing, especially, I always wanted for a long time combination of CPU and GPU. And NVIDIA has fabulous GPUs, and GPUs have become much more general purpose as NVIDIA has latest generation. But with Grace Hopper and now Grace Blackwell, the fact that CPU, GPU are close together gives a very great foundation platform to build science and AI on top of that.
But before we go to the next one, maybe just an announcement to everybody in this hall. Jensen is beating you over to the keynote. So I've been advised to tell everybody in this hall they need to make their way over to the keynote to grab your seat so that Jensen's not over there alone. Meanwhile, we're going to continue this conversation. One of the things, that has been a promise for a long time is how AI or how technology is going to advance human genomics, advance drug discovery. And I would say that there's been a lot of promise, and there's probably been less success than the world might have thought 20 years ago in terms of the transformation that would come. It feels to me like we've been laying down the tracks, right? The groundwork, the primitives for these big breakthroughs. And so my question to you is, are we on the verge of really solving problems that we've been talking about for the last 25 years? Yeah. Do you think the cycle time on discovery is about ready to change because of where we are in AI? And anybody who wants to chime in, but we'll start here.
Right, so I think we're at an inflection point, absolutely, and it's for the reason you mentioned. The tracks have been laid down, and there have been advances just in the last few years that have made it possible to achieve liftoff. If you think about the problem of drug discovery, and the conundrum that we face today, when you start working on a molecular target to make a drug, make the drug, take it through clinical trials and get FDA approval, on average that takes 13 years. 9 out of 10 drugs that enter clinical trials fail. The overall cost, including the failure, is about $2 to $4 billion per drug, and it's not improved in the past 20 years. And that's because drug discovery is still very artisanal. A lot of science, yes, but a lot of art, intuition, empiricism, trial and error. And at the highest level, AI, the promise of AI is that with the right kinds of data and the right amounts, we should be able to transform this from an artisanal endeavor into an engineering discipline with much higher success rates and shorter timelines. I think in terms of the inflection point, if you think about there are multiple applications of AI in the drug discovery platform. One is at the level of logistics, if you will, designing clinical trials, recruiting patients. The advances with large language models are already being put into action. We're seeing companies across the world implementing this to improve the efficiency of recruitment, identifying patients, filing reports to the FDA. All of those things are being accelerated in a dramatic fashion. The second area is in molecular design that's been touched on in the movie, and you talked about it, where instead of screening for drugs, we're designing drugs. Just as you can ask Sora to make a movie of 2 puppies playing on the beach, you can take a protein and say, I'd like to make an antibody, a drug-like substance that attaches itself in just the right way, and have the AI design it. A lot of action there, but the advances are recent. The Nobel Prize a year ago went to 2 groups, the DeepMind group, Demis Hassabis, John Jumper, and David Baker, our co-founder, for advances just in the past few years, AlphaFold, RF diffusion, RF antibody, that make it possible. So we didn't have those technologies 10 years ago, even 5 years ago, so that's prompting that acceleration. And then the last area, in some ways the hardest one, is understanding human disease, human biology and human disease, and getting those insights to figure out what should we make drugs to, and who are the patients who are going to respond. AI is just entering that area. That's also, I believe, going to build over the next few years. But we're seeing acceleration, very rapid acceleration in the first 2 that wasn't possible until a few years ago. And we're going to see increased acceleration in the third.
George, same question to you. Are we on the verge of a new cycle time in terms of discovery? Is the promise, I look at discovery and invention, and these are nonlinear systems, yes, right? And it feels like we're at a moment, because of all the technologies that we're talking about, that a lot of this promise is going to come to bear. What are you seeing through the lens of Lila?
Yeah, so this is definitely an amazing moment. There's the intersection of exponentials that have been occurring both in computation and in biology. For example, 20 million-fold reduction in cost of sequencing. And that's something we use not just to study the populations, but to guide experiments, to interpret experiments, and so forth. Just that analytic tool. But our synthetic tools are also getting better. I mean, our confidence in having low toxicity and high efficacy is making the clinical trials shorter. The record now, as far as I know, is baby KJ, which was 7 months from birth, diagnosis to cure with a gene therapy. And we are really actively using not just the dichotomy between screening and analysis and prediction, but putting them together. So you can use AI to design as well as you can, but then you make big libraries because there's some modesty that you can't necessarily design the perfect thing, but you can make these big libraries, and that combination is much more powerful than either one of them separately. So for example, at Dino and Manifold, we've made proteins that target the nervous system 100 times better, and they detarget the liver where you can get toxicity and absorption of the valuable drug. So those are just examples. This is happening now. This is not dreamy stuff off in the future. Yeah.
Exactly. So before I go to the next question, I have a public service announcement, and that is the pregame show is actually being broadcast inside of the hall. So as much as I'm sure you want to hear Brad and I and the guests, Jensen is a bigger show, and you want to make sure that you get your seat. Thank you very much. Okay, now to your regularly scheduled program here.
Yeah, one thing I want to add on drug discovery.
Yes, please.
And Cadence has a molecular science division. We are working with a lot of the pharma companies. Because a lot of the math and science is similar in chip design, which is very nonlinear to drug design. And something to watch is how much of the work is done on the computer versus how much of the work is done in the lab.
Got it.
And if you look at like 3 big areas that I'm involved in, one is chip design, and there 99% of the work is done on the computer, and you get first-time right silicon. Okay. Then the second part is system design, design of planes and data centers and cars. Okay, over there, 20% of the work is done on the computer, 80% is still done on the physical work. And then you go to drug design, molecular design. I think only few % of the work right now is done on the computer, and most of it is done. That's why the design times are so long. Okay, so what happened in chip design is most of the work moved to the computer, and then you can do modeling, which is accurate. Then you do simulation and optimization, which is basically design. So the more the modeling is accurate, more simulation happens, more optimization with AI can make drugs happen. So I think it is definitely on the verge. But if you compare to other established areas, it is still very, very early days in drug design.
Yeah, so Anirudh, I have. Oh, no, please go ahead, Mark.
I just want to add in terms of this transition to go from a few percent to 10%, 20%, 30%. Part of that is having accurate simulations. Eric Schmidt has a saying that is, I think, very profound, which is AI is to biology what math is to physics. Currently, for physical objects, you can model them using the equations of quantum mechanics or other things. For biology, we don't have equations. AI is the tool to make sense of biological data because AI can see patterns where we can't with the human eye. Of course, you have to feed the right kinds of data for that. So what we're in right now is a moment where we and others in academia and other companies are generating massive amounts of data to train AIs that will understand biology so we can have more and more of that stack in silico rather than in the wet lab. That, together with the automation that George talked about, is what's going to accelerate this.
So a follow-up question on that, and this is a bit of a challenge. I saw a recent report that said that China has 10x more drugs in the hopper than the United States does, yet we have 10x the amount of data centers that they do, and probably even a lot more compute power. What is that disparity in, I'm not talking about trials, I'm just talking about the creation of it. Why are we falling behind, and what needs to be done to accelerate this?
Well, I wouldn't say we're falling behind necessarily, because there's quantity of drugs and there's quality, and whether, a game-changing drug is one that reverses aging, because 90% of us are going to die from that. Right. But you can make a whole lot of Me Too drugs that don't really solve problems. That's part of it. I think in addition, they do have some advantages. Like they have this IIT system, investigator-initiated trials, which are very streamlined and seem to be dodging anything having to do. They seem to not be running into problems with toxicity. With the focus on lowering that toxicity problem. So I think it's healthy competition.
Yes.
But I think we're quite a bit ahead, partly because we are integrating computation so smoothly with it right now.
No, I appreciate the clarity on that for sure.
I actually one of the questions, and feel free to chime in there as well. But one of the questions I have around quantum is, I think for the average investor, for the average observer, they see these stocks flying. They think it's part of the meme bubble that exists in the world. They have no idea when the benefits will come. So for somebody leading a company, like Inflection, where you have real customers that are leveraging this today, help the viewers at home understand, like, what is the important consequence for making these investments? Are the stocks today in the quantum universe, are they ahead of themselves? Like, do we have some of these mini bubbles where everything is getting pulled up? And because I think deflating that and providing a real set of context is important for the longevity of the industry.
Well, Brad, just for some context, and you know this, but before I came to be CEO of Inflection, I was an investor for 19 years. And so one of the things I did learn as an investor is never give stock tips to friends, because you're going to be wrong more than 50% of the time. And so I will punt on any commentary on the stock prices of the publicly traded quantum companies. But what I will say is the reason this matters is going back to where we started, unlocking the power of quantum mechanics and turning that into products will result in orders of magnitude improvement in those types of products. And so we're not talking 50%, we're not talking 100%, we're talking 10,000, 1 million X improvement in performance. And so going back to what I was saying about how we followed Jensen's strategy on how to monetize and commercialize and build the market for ourselves in quantum and actually kind of show the world that quantum has real advantage today, is we pointed this at areas where it already does have those types of 10x, 10,000x, 1 million X improvements in performance. And so timekeeping, RF antennas, things like this, sensing, those are real market opportunities, to your point, where there's real customers and products today. So part of it is, I think you can look to other areas than quantum computing to see real quantum advantage. Now, when will we see advantage in quantum computing? That's the big question everybody wants to know, right? It all comes down to logical qubits. Logical qubits are really the keys to the kingdom in quantum. And this is one of the ways that AI and quantum are really going to interact and be tightly coupled, because AI helps us get to logical qubits faster. Because logical qubits are error-corrected physical qubits. So they're sort of these pristine qubits that you can actually use to do computation. So up until 2023, the world did not have logical qubits yet. We weren't even sure if we could get them. In 2023, we saw the first logical qubits. Today, Inflection and a handful of companies have logical qubits. We announced that we had 12 as of a month ago. And it's generally believed that about 100 logical qubits, you'll start to see quantum advantage in areas like material science. When you get to 1,000 logical qubits, you'll start to see quantum advantage in areas possibly like drug discovery. And as you scale those logical qubits, you'll see quantum advantage in areas beyond those. And so I do think this will be absolutely game-changing technology. I left a great career at a firm called Maverick Capital to come do this full-time, because I see the opportunity ahead is absolutely huge.
So I have to ask George and Mark, I mean, you're using GPUs today. We'll call that, it's hard to call GPUs classical computing. I think that is CPUs. So CPUs to GPUs. How are you looking to quantum to help change what you're doing? Because quite frankly, if I look at the algorithms that they're working on and what they do, it would seem like there would be an opportunity, maybe not immediately, but maybe in the future.
Mark, you want to start?
Well, in terms of which kind of going from CPUs to GPUs to quantum compute, or what?
Well, we're going to have a world. I mean, listen, as we know, nothing goes away. We'll always have CPUs, GPUs, and we'll have quantum, which will assist it.
So we're like many companies like ours that are doing, applying AI to molecular design, AI to develop foundation models of biology. We're big consumers of GPUs, obviously. what we're doing. There's certain applications where really having the power of quantum computing would come in very, very handy, in particular for molecular dynamics simulations, which right now require, basically much more compute than what we like to deploy. So we see lots of use cases where we could leverage that kind of technology. For now, we can run with the technology that's being made available by NVIDIA today.
I mean, one thing to add on quantum, and we work with a lot of the quantum companies as they design their computers, and quantum is very promising, especially for certain applications. It can give a huge speed up. So we are, closely watching when it gets to scale. But I think future will be hybrid. I think CPUs are still important.
Oh,
GPUs
absolutely.
are phenomenal. FPGAs, custom silicon. So I think it's not an either-or thing. Quantum will have certain big applications. It will give dramatic speed up, but all the other hardware platforms will work together to solve
I completely agree with that. I think just as GPUs layered into the data center and enabled new capabilities of what we could do with compute, QPUs will start to slowly layer into the data center and just expand what we can do at with compute. And I think it'll result in more CPUs and more GPUs being deployed and sold because we'll be now addressing problems that just weren't able to be addressed with compute historically.
I mean, maybe one of the, as we begin to reflect on the day heading into the keynote with Jensen, in my world, the world of investing, the talk really is about, a bubble and whether we're ahead of ourselves. That's where we started the conversation. I think it's super important that we kind of steal people's minds for the fact that this is not a straight line up and to the right, as we look ahead. So as you take yourself out of the position of running your companies, but just as an observer of technology ecosystems over a long period of time, when you hear all of the deals announced over the course of the past many weeks, trillions of dollars of compute that's getting built, what concerns you the most, right? As you're running your company, as you look ahead, what do you think could upend us? What do you think might be that risk that causes this to slow down or us to get ahead? Are any of you concerned about, kind of the dark fiber and the GPU overbuild that you certainly hear talked about on CNBC every day?
Well, let me start. And I mean, what is promising for me to see is that, there is still a lot of demand from our customers, the big companies, to build more and more compute. And the way I think a lot of people don't quite grasp that there are multiple phases of AI in my mind. And we are in the Horizon 1 or first phase, which is the infrastructure build out, build out on the cloud, on the edge. But there is Horizon 2 and Horizon 3 phases, which can be even bigger. So the first phase is infrastructure, LLMs, and if you look at that first phase, I still see, talking to all the big customers, years of growth in compute and AI capability. But what is even more encouraging to me is phase 2, which I've always said for years is going to be physical AI. AI is not going to be restricted to the cloud and to software applications. It will move to the physical world, which is cars, planes, drones, robots, and that could be trillions of dollars of monetization. And then phase 3, even though we are already doing science now, but science is AI to me is the Horizon 3 application with drug discovery, with material science. I mean, these are trillions. So I think we are only in Horizon 1.
Yes.
And talking to customers and partners, Horizon 1 still has years of legs. And then you add Horizon 2, which is physical AI, Horizon 3, which is science is AI. I mean, this is a long way to go still.
It's a great framework.
And I think we're seeing the same thing in our field. In phase 1, the availability of the algorithms and the compute means that it makes sense for us to try to generate data at scale. Previously, we couldn't have made use of those data or interpreted them in the right way. So we're going to have that build out. We're going to see the permeation of AI in all aspects of the laboratory. That's how people will analyze their data. It's going to become just routine and baked in. So I see steady growth, and especially with automation of the kind that George is thinking about. But also, I think it's important to try to set expectations right. It currently takes 13 years to go from starting a drug discovery program to having FDA approval. we're not going to get it down, that whole 13-year process down to 2 years. Right. Can we get it meaningfully down to 10 years? I think we should give ourselves the ambition that over the next 10 years we get down to, we cut it in half and we cut the attrition in half. Those would be huge gains in terms of bringing life-saving therapies to patients. But we have to be realistic. Some of the AI companies that started before we did are already going very quickly from starting a project to getting into clinical trials. One of the ones, there's one that announced recently, within 2 years, they went from starting a project to getting clinical trials. Normally it takes about 5 years to do that. So I think we're going to see meaningful improvements, but you also have to be realistic.
But we already have an example of 7 months. Yeah. So let's not say that it's that far off necessarily. Right. And to the hybrid strategy, I think we already energy is going to be a big thing. And if we look at biological intelligence, the energy consumption there is 12 orders of magnitude better if you talk about petaflops per watt. And so we need to look at that as an example. So we'll have hybrid systems. We've already made single molecule transistors in a CMOS system. We published this 3 years ago. We're going to see more of that, molecular electronics. So hybridizing with quantum, which is quite different.
Well, looping back to Brad's initial question, which is the bubble bearers, it sounds like, and I say this tongue in cheek because I'm an optimist, is you could do some pretty useful things with 100x or 1,000x more compute. I mean, you could make life-saving drugs out there and things that can literally cure diseases that have never been cured before.
I mean, I think the way my mental model is there's an enormous investment cycle going on here, and a return will need to be earned on these investments. And so I think it all comes down to, do you believe a return is going to be earned on these investments? And I guess you could say, are the investments leading to useful things? And it sure seems like they're going to be useful. And so the question is, what kind of return are they going to earn on these investments? And so
and these multiple phases, we reinforce the previous phase. So if there's infrastructure AI, physical AI, sciences AI, in physical AI, when we deploy AI to robots or cars, of course, the car itself has an inference chip, like in a Tesla or in a robot. Yeah. But the model, the new word model, still has to be trained on the data center. So not only the infrastructure AI is strong because of software application, when physical AI happens, it reinforces the data center. Same thing with sciences AI, it will reinforce the data center, and also in medicine, there'll be a lot of robotics that helps. So these layers not only are good by themselves, they reinforce the previous layer.
Yeah. Gentlemen, this has been an amazing conversation. Science and quantum. We got a special guest, Jensen Huang, come up here and literally add some serious value here. So thank you very much, and hopefully I'll see you on the floor.
Thanks. Great job moderating, guys. Thank you.
Thank
All right, folks, let's check back in with CNBC's Kristina Partsinevelos. Kristina, we're talking here about quantum systems and a lot of science. What do you think is the smart investor play?
Wow, way to put me on the spot. Remember, I'm a journalist, right? So I got to remain unbiased. And I actually am going to pivot and deflect your question because I don't want to weigh in on quantum, even though I'm learning quite a bit from just even how to stabilize the atoms. One of the points that Jensen was on the panel with you very quickly, he spoke about, having GTC here in DC because he thought President Trump was going to be here, and then 2 days ago he moved on to Korea, and we know why. Could you guys both maybe weigh in on perhaps China reopening as a market? Because I know it was a financial conference not too long ago where Jensen Huang said that they're 100% out of China at the moment. They're still working on getting those licenses. So maybe Brad and Pat, you could both weigh in with your thoughts on the Chinese market and what we could expect out of conversations later this week.
Well, Kristina, I mean, it's an extraordinary week. The president starting in Malaysia, going to Japan today. And then we just heard from Jensen that he's going to meet the president in Korea. And if they get a deal done as speculated with China, I think it's an extraordinary tailwinds to the market writ large. Remember, if you think about where we were in April of this year, the NASDAQ was down 20% on the year. Everybody was panicked about whether or not tariffs would upend the global economy. Now it seems like we've landed the plane on global tariffs, that we've gotten the big beautiful bill passed, as you know, out of Washington, and now we're into a rate cutting cycle. I think that there's a very good chance, because logic is on the side of NVIDIA. NVIDIA had 95% market share in China. Today it has 0.
Right.
If we want the world to run on the American AI stack, we ought to be competing everywhere in the world with America's AI technologies. That's included in China. And so to me, it'll be an interesting question. Do Secretary Besson and the President, use rare earths in some of these trades that are going on to allow chips to be sold in China? I certainly know where NVIDIA stands on this. And as Jensen and I talked on my podcast, there are some of those who say all he cares about is selling more chips. But those of us who know Jensen know that he's an American patriot first, and he wants the U.S. to win the AI arms race when it comes to AI. 40% of the researchers and developers in AI are in China. They would prefer to use the CUDA ecosystem and build on NVIDIA chips. So let's hope that certainly, if not this week, that in the weeks ahead, U.S. chips are back in China. I think the markets are currently saying no NVIDIA chips in China. NVIDIA has told investors not to include it in their guidance. And so we'll see. But I think there is a chance, because I think logic is on the side of NVIDIA being able to compete in China. I think it's good for the U.S.'s race in global AI.
Okay.
Yeah, Brad, really nailed it here. And I'm glad you hit both the import and the export portion of that.
But I actually have a special guest right next to me that we can continue this China conversation if you guys don't mind, and give you a little bit of a break. Anirudh, the TV magic, you just came off of set. This is the first time I'm meeting you cold turkey like this, so thank you for doing that quick move. Congratulations on your quarter as well. I was going through the transcription last night, and there was a few things that stood out. You said EDA tools would become standard. More specifically, you said, quote, monetization approving over 2 contract cycles. So when could we start to see more meaningful revenue from this shift, if you're saying just within the next 2 contract cycles?
Yeah, hi, Kristina. Great to be here.
I know, it was like a hard question.
Yeah.
Boom, right into it.
Well, we announced our earnings yesterday, and we raised our outlook for the year, both from a revenue and EPS standpoint. So we are very pleased with the performance. Our revenue this year is going to grow 14%. And we always focused on revenue plus margin, and our operating margin will be close to 45%. So we are pretty pleased with how we are able to monetize, of course, chip design and AI applications into chip design.
But sir, maybe I'm not understanding. So does that mean in 2 cycles from now we should see a meaningful increase? Is that what you were implying in that statement?
No, my statement is that we are also infusing. So Cadence has like 2 ways we are participating in AI. So one is design for AI, the other is AI for design. So when I say design for AI is the build out of the AI infrastructure. So we're working with most of the big AI companies as they build out chips and compute. And my comment on 2 contract cycle is on the second part, which is AI for design.
Okay.
So not only we are helping out build the AI infrastructure, we are applying AI to our own products to make them more efficient. And in any new technologies, we are very positive on the impact of the technologies, but we are always prudent in terms of when it will translate to business. And normally we have seen over the years that it takes some time as customers try it and then deploy it. So the deployment is very impressive. Most of our top customers are deploying our AI tools, and then we hope to monetize as we move along. Yeah.
Speaking of monetize, maybe monetizing China could be a topic, since I promised Patrick we would continue that conversation. If I remember correctly, it's 18% of total revenue, correct? In the market. And there was a concern that maybe there was some pull forward given the constant back and forth with what's going on with China. Can you just speak to maybe, was there some pull forward? Was that what you were seeing from Chinese customers in particular?
So China revenue, if you look on a yearly basis, is about 11 to 12% for Cadence. And what I would like to say is that most of our business is in the US, about half the business is in the US. And rest of the world, we are very diversified across all, we work with all the major tech centers and countries. And so we're glad to work with China, but we also work in India, Taiwan, Japan, Israel, Europe, in all the major tech centers. So, since semiconductors are so essential to everyday life, but overall our China business, I think, is about 10, 11%. And, but it is higher in Europe, it's higher in the rest of Asia.
And the settlement is clear now. I think it was like $140 billion, right?
Mm-hmm.
So that's done.
Yes.
All done. Lip-Bu Tan, the current CEO of Intel, used to be at Cadence. What do you think about what they're doing at Intel? Do you think that process of getting investments from SoftBank, the US government stake, NVIDIA partnership, et cetera, what are your thoughts on that?
I think Lip-Bu is doing great at Intel. You know, we're glad to partner with Lip-Bu. He's making all the right moves. And just like we are great to partner with all the leading companies. You know, we worked with NVIDIA for about 20 years. So our goal is to do innovation, provide products, and to our customers so they can build even more amazing products. So we are fully supportive of all the efforts with our top customers.
And we'll end with just the relationship with NVIDIA. Could you speak to just, I know you were on your panel and you were chiming in on physical AI, you're talking about how your tools are going to be used, but could you just elaborate on how the relationship has changed with NVIDIA, even within the last year or two?
Yes, it's remarkable. First of all, Jensen is a true visionary. You know, what he has done and the impact he's happening on multiple industries. And we have worked very closely with Jensen and NVIDIA over the years. And the relationship has really, blossomed even further in the last few years. And, first of all, they use our products to build their products. That's the essence of our, that's how the relationship got started. But then over the last few years, we are also using their products to turbocharge our products.
Right.
And what is really impressive to me is how general purpose GPUs have become, And now with Grace Hopper and Grace Blackwell, the combination of CPU, GPU together in one accelerated platform, along with AI, it can give a lot of speed up to our product. So we jointly announced a product 6 months ago, which can give up to 80x improvement and up to 20x lower power using the NVIDIA accelerated platform. Also in software. So our partnership on Omniverse, of course on CUDA, on Nemotron. So it's a great, partnership with NVIDIA, and we really cherish that relationship.
20 years, right?
Yeah.
I got to leave it at that, Anirudh, and I'm going to see you soon. We're going to go keep this conversation going. Thank you so much.
Yes,
and to our audience here, I'd encourage everyone to head over to the next hall because the keynote is very, very soon, which is why I need to wrap. So back over to you guys.
Yeah, that's what I'm hearing, Kristina. If we don't get over there and get our seats, I know everybody's grabbing free food and coffee. Patrick and I, we have reserved seats over there.
We do,
but
yes.
I think if you don't have a reserved seat, you need to get over to the main hall. We're about ready to light it up with Jensen, and it's going to be an exciting day. But Patrick, before we do, we've saved the best for last, so why don't you introduce us to our last panel on robotics?
That's right. So robots aren't coming. They're already here. In fact, AWS even announced that they had 1 million robots here in the US, but in other countries, they have a lot more. And whether it's for factories, for operating rooms, accelerating computing is training robots in simulation and deploying them into real world faster than ever before.
I mean, it's the bridge between simulation and reality. Training robots to build, move, and even operate with precision, once thought impossible. Here's how AI and robotics are powering a new industrial revolution.
The age of robotics has arrived, reshaping every industry, where everything that moves is robotic. In the operating room, at home, our warehouses, and igniting modern manufacturing.
Physical AI and robotics are moving so fast. Everybody pay attention to this space. This could very well likely be the largest industry of all.
The physical world is becoming programmable, and this fusion of intelligence and industry is creating new types of factories, new jobs, and a more resilient manufacturing base. The leaders driving that transformation join us now. First, we have Peter Coatue, Chief Technology Officer and Chief Strategy Officer at Siemens AG. We have Young Liu, Chairman and CEO at Foxconn. We have Brett Adcock, Founder and CEO, Figure AI. And we have Aki Jain, President and CTO, Palantir US Government. So, Great to see everybody here. So, Young, I want to ask you the first question. First of all, my relationship with Foxconn goes back to 1995. And I don't know if they call that experienced or old. But you are one of the biggest manufacturers for all precision goods, from smartphones to hyperscaler data center equipment and pretty much everything in between. Talk to me how AI and robotics is transforming what Foxconn does.
Okay, first of all, thank you for having me here. This is a very great event for technology companies these days. You know, Foxconn is the largest manufacturer in the ICT industry. And we used to be very much labor intensive. And then we transformed it to automation intensive. With new generative AI technologies, we think the AI intensive manufacturing is coming. And with this new technology, this is new and disruptive. We'll have to work with industrial leaders or technology leaders like NVIDIA, Siemens, and the friends at this table together, to be able to catch up and apply the new technologies to our manufacturing facilities. And currently, we are building up factories, here in the States, in Ohio, Texas, Wisconsin, and California. And we think the AI era is coming. And I call this Industrial 5.0.
That's excellent. Peter, your company is known for being in all of the connective tissue inside of manufacturing. And I'm curious, how is AI making manufacturing in the United States more competitive? Because that's a big talk, particularly here in Washington, D.C. And quite frankly, it has a lot to do with, and Brad pointed this out in an earlier segment, even national security.
Right. So we believe that AI really will be a key driver for the establishment of manufacturing yet again in the United States, which is going to be smarter. So we think of it as more of an AI native factories that we want to build. So it starts with the sensors, right? I mean, the sensors that you all carry and that we all carry, we love the data. And because we got so many sensors now everywhere, humans cannot make sense out of this anymore. So therefore, you need to automate that. And so as we build now factories, we build them always twice. We build them first in the digital world, and we optimize them, and we see how you place the machines, how the material will be flowing, how humans will be interacting with machines. And then we optimize them over and over and over again until we finalize, think, this is great. Then we build the real thing, so with the real factory, but still you got the real one and the digital one, and they talk to each other. So whenever you have like a supply chain glitches that we used to have, remember the semiconductor shortages, you actually can go to your digital model and you can look at it and say, what if actually this part is missing? What will the implication on, of course, on the shop floor? And that gives you unprecedented speed, it gives you unprecedented productivity, and of course, sustainability and energy efficiency. And I think this is vital as we think about the next generation of manufacturing blueprints here in the United States, which is very labor constrained because we don't find enough people to fill all the factories. We have to automate that, and Siemens is a key part of bringing manufacturing back to the United States.
Makes sense.
Hey, Brett, a lot of people talk about Tesla and Optimus, and what they may not know is that Figure AI has emerged as a startup from a small startup to a real leader in humanoid robotics. We heard you earlier this morning jamming with Jensen about the things you're doing with NVIDIA to put you at the front of that pack. Tell us a little bit about Figure, where you are, and how the relationship with NVIDIA is so potent in really launching you into a leadership position here.
Figure is trying to basically build humanoid robots that can do everything a human can. You can't code your way out of that problem. Mathematically, we have like 40 different joints in the robot that can ultimately be in, every joint it's a motor, can move like 360 degrees. So you basically have 360 to the power of 40 equals the number of states the robot could possibly, like the basic body positions.
Yes.
It's like more than atoms in the universe. So it's just, you have to solve this with neural nets. And so for us, we have this like kind of phrase we use where we're trying to give AI a body and to do everything a human can. So that means everything from pre-training, like we have to basically build like large-scale data collection efforts of human-like data to do training. We use NVIDIA there. And then that means at test time, when we're running policies on robot, we're doing inference on NVIDIA GPUs on robot without any network connection. So we can basically run robots in full end-to-end situations like doing work without any network, outside network. So for us, we think of ourselves like an AI business. We happen to be building like these physical agents around the world, like similar to web agents, basically just like in the physical world touching things. And NVIDIA has been a very significant partner and investor of ours, and I think they will be significant in the future as well.
And you guys today, just give people a sense as to where you are. You know, when did, you know, we heard 1 million, robots out at Amazon. Like, how should we be thinking about how many humanoid robots you guys are going to be producing, 2 or 3 years out?
I think, to be candid, the problem that the entire space feels for humanoids is we have to solve like a general purpose robot.
Yeah.
You have to get to be able to like just talk to it and have it do anything you'd want it to do in unseen locations. That problem is not solved. That problem is 10 times, 50 times, 100 times harder than making a humanoid robot, in my view. So the hill we need to climb, or the hill we're trying to hill climb now, is how do we build a horizontal AI stack that can do everything a human can? And quite frankly, we have robots that are working in the commercial market as of right now, like to this very moment. And it's been really good for us to get those lessons learned, but it also gave us insight to build like what is the right technology stack to go build? And that technology stack is like end-to-end deep learning. And so I think for us, we're trying to hill climb that problem. In parallel, we've now announced BotQ this year, which is our basically high-scale manufacturing facility out in California. We do all final assembly testing and robot shipping from there. And that problem is hard. It's more like a consumer electronics manufacturing problem, but it's not, it dwarfs in comparison to solving a general purpose humanoid robot, which is just like on the surface, just like an incredibly hard problem. It's tractable, it's an approachable problem, but that's the problem we need to solve first. And then from there, we need to figure out how to manufacture at scale. That's like heavy automation. We need robots in the loop for end-to-end manufacturing. And we're doing it now in-house. So we figure out how to build MES systems, how we build lines, how we do end-of-line testing, how we deliver it to customer and make that better and validate it. So we're basically trying to get good at manufacturing while we're trying to solve the problems of like, how do we solve how do we basically solve general robotics?
Yes.
Yeah.
Aki, Palantir, I heard Alex say the other day, Alex Karp, of course, that you're solving the ontology problem that sits between silicon and, and getting useful outcomes for companies, for businesses, for physical intelligence. Talk to us a little bit about how you think about the role that Palantir plays in, bringing us from the promise to reality.
Yeah, absolutely. So if you go back to the core of what Palantir is all about, you have all these data systems, you have ERPs, MRPs, random software that people have built in the ecosystem, and all those kind of systems solve a specific problem. They have different security frameworks and whatnot. How do you provide the ergonomics, whether it's for an autonomy stack, whether it's for a factory worker, whether it's just for a human to actually answer questions about that business and optimize it? And that's really what the ontology is. It's kind of that agility layer. Your different data stacks integrate with it. They provide the security, the privacy, other controls around it, and they provide the ergonomics. The AI yet. When Brett's done, the AI will be able to walk down the hall, and kind of sit at the water cooler and learn things about the organization, learn things about the IP, learn things about the processes. But right now it can't, right? The way it can is actually interacting with APIs. And so the ontology ends up serving as an SDK for the AI, for the agents, for the models, whether the awesome NVIDIA open models, Nematron, Cosmos, some of those capabilities, or the proprietary models. And Foundry and AIP, on top of the ontology, provide the ability for humans to orchestrate those models to achieve goals. So at the end of the day, kind of the core insight is if you reframe the data, which is what we do, into the ontology, you can reframe the operations of a factory, an organization, kind of any process at scale.
Maybe, I'll start with you, Aki, on this, and we can go across the group. We've talked a lot today about open models. I think NVIDIA's contributed more to these open source libraries than any other company on the planet. We'll hear more about that later today. What do you see, really being employed in industry today? Yeah. Right? We obviously have these frontier labs that are producing these incredible models. But what do you see in terms of, the hybridization, maybe the ensemble model approach, maybe, some Chinese open source models that you see being leveraged by U.S. companies, et cetera? I'd be curious what you see out there on the front lines.
Yeah, well, I think right now, at least from Palantir's perspective, both across half of our business is commercial, half of our business is global government. And what I would say is, look, we always start with the big heavy cloud model from the frontier lab companies, and there was proprietary models. I got to be honest, they're moving so fast and they're so effective. So we use them, to solve any problem is the first thing we try. But we're finding more and more, especially as we move to the edge, as we're thinking about inferencing at the edge, we think about the need to start to take those models, train them on bespoke data, and then move that towards kind of more of an edge inferencing architecture that solves specific problems, either with a small language model or even something that maybe is just a traditional machine learning model for a lot of problems where data becomes critical. So we're seeing the trend of open models and the ability to take those models, quickly refine them, and kind of get to something that solves a specific problem at a low swap is being really critical.
Yeah, I would concur. This is it usually starts horizontal. The horizontal ones are more open and by nature, but once you get into the use case specific applications, then actually they become more closed because you have to retrain. So as an example, we are doing a model that helps to machine programming. Right? In the US, we're going to miss 2 million people by 2030, and we don't find the people that are skilled to do that. Yeah. So to program a machine is a very specific code, and so we take a general language model, and so a large language model to apply it, but then we do all the racks, all the training, retraining of it in order to make this work, and then we are held liable for actually really that this works. So therefore, you need to close it to some extent that you get a little bit of a control over what the quality and the results are.
Yeah. Another line of question I'm interested in, we, again, back to this question about the global AI race and the reindustrialization of America. You all have a role you're playing in that reindustrialization. Foxconn has made some major announcements about investments it's making in the United States and frankly, about data centers that you're building in partnership, with NVIDIA around the world. Talk to us a little bit about how you see your role in the reindustrialization of America.
Yeah, based on our experience in terms of the level of AI intelligence for the manufacturing, and we found there are 3 levels of intelligence. Level 1 is for the simple and fixed operations. Level 2 is for simple but flexible operations. Level 3 is for simple, but complicated, but flexible operations. Right. Now, with these 3 levels of intelligence, it requires large compute power to do the training and the inferencing. And with that, that's why we're building a lot of AI-related facilities in the States, as I mentioned, from Ohio to Texas to Wisconsin and California, in order to support the demand for this compute power. But besides the compute power that is needed, we also need talented technicians and engineers to apply and to use these technologies. And that's another challenge that we're facing. Yes. That's something that we will have to do together with the government to have education that is steered towards this. Okay.
Great point. Brett, I know that you and Elon are leading the charge on robotics being built in the US, right? And obviously China famously has some leads in autonomy and in robotics, et cetera. Handicap for us, if you will, how you're feeling today. What's your level of confidence that we're going to be able to compete effectively on the global stage, both from a capability and a cost perspective in robotics? with what's coming out of China?
I get this question a lot, and I have a very strong opinion here. Like, I think what really matters today is we see the core, like, horizontal technology stack, both in hardware and software and AI, come together to build, like, general purpose, like, almost like human-like intelligence in the physical world. Like, that's the key unlock. Like, I can't stress that enough. Like, people are looking past that in terms of costs and manufacturability and all this different stuff. We're at a stage now where we got to go build, like, synthetic humans. And it's incredibly hard. And I think what we are proud about at Figure is we've been able now to show these, like, real, like, pockets of, like, long horizon intelligence done with neural nets. I think the shortcomings are that we couldn't put them into a house that's unseen today and do, like, hours and hours and hours of work. We want to get there. We think we will get there. But we've seen all the ingredients of the puzzle pieces to be able to show that that is going to happen. I think we've been leading that globally. I think if you're going to say, like, okay, here's a robot now out in the real world that needs to run all day with like low human intervention rates, like low faults, like we've been able to show that both in the commercial market and the work we've done in-house. I think we are, like, in a lot of ways miles ahead of other competitors we see in China in that aspect. From there, once that is solved or close to solved, it does become like a manufacturing game. This is a consumer electronics manufacturing process. It's not an automotive manufacturing process, which means we have, like, different piece parts and electronics that we need to fabricate. We need to do FATP. We need to do integration, EOL testing. We do all that extremely well. I think that is, like, an extremely tractable and surmountable problem that you can do even at scale. I mean, we produce, what, 1 billion phones a year, almost, like, by hand in some way. Like, we can definitely create, like, millions and millions of robots, like traditional consumer electronics manufacturing processes. But what is not solved is be able to do, like, real end-to-end general purpose robotics. And I think the US today, at least we can say what we know at Figure, I think we're leading that head and shoulders globally. And we hope to continue to pull away. Like, I'm going to be jumping on a flight right after this to make the engineering stand up in today to try to continue that and pull ahead.
Yeah. Brett, there's been a lot of discussion, doubts around, a general purpose biped robot that can operate in the home and in the factory. I mean, you got so many people. You dropped a video of one of your robots folding laundry, and I mean, everybody went nuts. Like, hey, I want one of those. But I'm curious, where does the technology have to be where you can confidently serve both of these markets? Maybe put one of them into Young's factory as well.
Yeah,
we can do a deal here on stage.
Let's get a deal done.
Sure.
You ready to do a deal? Yeah, let's do it. There we go. Listen, I think one thing we're proud about is we have a robot running right now. And our first commercial customer, it's running like a 10-hour shift as we speak. We've been doing it for almost 6 months now. We've gotten, like, operational readiness there. It's running autonomously. We've been trying to track, like, fault rates, like human intervention rates per shift. Those have all been dropping. Performance has been rising every single month. So we now have a better line of sight to what it takes to launch, like, a vertical job in, like, a commercial world. What we're also trying to tackle, and what we found, like, learned a lot last year, is we need to solve, like, the horizontal stack. Like, we need to be able to build true general purpose work to put robots into anywhere in the world. So we've basically refactored our entire, like, autonomy and AI stack from scratch. It's all done now end to end with neural nets. We think it's the only way to really scale, and it's done at the foundation level, so we can scale into any work. So I think, maybe to answer your question more directly, we will see robots in the commercial workforce over, like, now, and in the next, like, year or two. We will try to put more and more out. We will try to get we'll try to get cost down, reliability of the robots up. We'll try to make it really real. In parallel, we're trying to solve a robot in a home. It's been in my home now for, like, 3 or 4 months. Wow. We're doing small parts of this, like small parts of laundry and folding and dishes. We now have to connect all of it together, like this tissue. We have to make it language conditioned so we can talk to it. We have to put it in pixel space. So there's, like, a bunch of work in, like, AI models and foundation work and pre-training that we have to go do. But we do see a path. It's like a little light in the tunnel that we want to go at. It'll definitely be solvable. This, like, in this decade, like, it'll be solvable hopefully in the next few years that we can have this work. So we're excited about that. But that is, like, more of like a car autonomy in a city versus car autonomy in a highway. They're very different. One's, like, super unstructured, high variability, and, like, a lot of the engineering challenge is proportional to that variability. So, like, we're going head on at that problem. I would say you're going to see them in the workforce over the coming year or two. And then we will only launch a product in the home, in the workforce, at scale, once we feel confident of the product.
Right.
We will not do it early. We will not teleoperate them in market. Like, we will not do any of this silly stuff. And I think that's maybe differs from other groups maybe in the space, but we are trying to build like end-to-end autonomy with low human intervention rates in this commercial end market. So once we're able to like really sell into your home, to Brad's home, we want to be really confident it's going to really work and it's going to be really safe.
Can I give you my credit card now?
We'll take it.
Okay.
We have a little machine in the back. We'll start. We're happy to punch it.
Aki, you guys have long been important partners to the U.S. government. We obviously have had a major changing of the guard over the course of the last year. A lot of people, including Jensen, have said that this administration is far more open to Silicon Valley and technology companies coming, sharing their concerns, sharing their complaints, and getting deals done.
Yeah.
Talk to us about how you're feeling about the state of, industry-government partnership today versus what you've seen over the course of the past, many years.
Yeah, I mean, this is year 21 of Palantir for me, so I've seen it all.
Yes,
to be very clear. It's like night and day, right? And that's not a knock on the prior administrations. I just think you had a particular status quo or way of doing things, and industry was often held at bay. And Silicon Valley, frankly, I mean, part of why we moved our headquarters to Denver when we went public was, very much a monoculture. You couldn't have disagreement. You couldn't actually discuss national security and the importance of national security to Silicon Valley and vice versa. And so I think what you see is kind of both at the intersection of the administration, taking on some really hard, gnarly challenges, at the same time as generative AI is coming through, is kind of, when you think about AI infrastructure, is kind of the way of the future. When we think about, how we're going to build things, how we're going to make sure we do reindustrialize and bring a lot more capability back to being built in America, you kind of have this perfect storm in the moment and the people. And what I've been incredibly encouraged by is the openness, right? Look, every administration gets something wrong, but that ability to say, hey, that doesn't look right, and to give feedback, and frankly, for people to take calls and kind of hear that feedback from industry and think through, hey, how do we make this great for government, for every American, and for industry, I think is unparalleled. And I think that that's kind of what we're seeing right now. I think it's also then kind of on the back of that driving a huge resurgence from Silicon Valley to say, hey, we want to be, I mean, Jensen said this so many times, if you're doing work in technology, you need to spend time in DC, you need to share what you're doing, and you need to talk about how it's going to help every American out there kind of as they kind of think through this. Otherwise, there's going to be a lot of fear, uncertainty, and doubt out there. Yeah. So we also have this responsibility as technologists now to kind of share that vision, share what we're doing, share how it's actually going to help, and kind of bring the American people along. And this administration is doing that in spades. So we're thrilled by it.
I'm curious if you guys share the same experiences vis-a-vis Washington. I mean, I think one of the critical things this administration did was to name David Sachs, the czar of AI, so that there was a technologist, a point person who could frankly walk into the White House and help break through some of the largesse that just is institutionally part of Washington. Have you all shared similar experience that we just heard as it pertains to getting stuff done in Washington?
Absolutely. The willingness to listen, but also then to take actions and to implement is really, really key. And in particular, to be pro-business, understanding about where regulation is required, but where isn't. And in the industrial world, we have business-to-business relationships where obviously we have professional terms that govern the quality of service, where you don't need a lot of regulation, and where it's about speed and really making it accessible. And so we find that a very friendly way to bring that technology into the United States.
Yeah. We felt the same way. I think this government is quite open to the technologies and very supportive to the new technologies.
Right.
Yeah. So
that's good. So, Peter, Young, Brett, Aki, I want to thank you for coming on here. We saved the best for last, and you guys were awesome. Thank you so much.
Thank you.
Thank you.
Thank you.
So let's go back down on the floor with Kristina Partsinevelos. You have one more interview, a very special guest.
Yeah, also the best for last, and that would be CJ Muse from Cantor Fitzgerald, who's been in the industry forever. We were just, but he looks really young. I shouldn't preface like that, but could you speak to China right now, given that is a topic? President Trump was supposed to be here. We're in DC. Some people say the markets moved on Monday with the NASDAQ really climbing because, there's maybe some positive outcome given Trump's comments over the weekend that something may be worked out. So how are you looking at it from a chip analyst perspective, and how to read that for the market going forward?
Yeah, absolutely. And Kristina, thank you for having me first. But I would say China's a very important market, and we don't want to cede that to local competitors inside China. And so I do think that there is a deal as part of the grand bargain where NVIDIA will be able to ship, as well as AMD, into China. And so I would assume the deal on Thursday, President Trump, President Xi will include the ability to ship GPUs. And so Jensen's hopping on a plane after GTC, and I would imagine that will be an announcement that we hear on Thursday.
That's pretty big. So you're telling our audience that you're expecting a positive outcome, which do you think it's actually priced into a lot of these names then?
I don't. I think, China's a very large market. You're talking $15+ billion, and I think that opens up. So no, not priced in at all. And that helps both NVIDIA as well as AMD, yes.
Okay, so that is good news for those that are watching and figuring out which stocks to buy. And we're going to talk about just Washington, and we're here, right? And this involves a lot of collaboration between policy leaders, really getting the president on board, the White House, the administration, which we know they already are, given all the initiatives thus far. But when you have these headlines from OpenAI or NVIDIA or AMD, Intel, et cetera, they're building, they're collaborating, and yet you still need to bypass the red tape. You need to build in the ground. You need to find the power. Are you worried that perhaps the market is reacting too positively to news that these outcomes won't happen for another 10 years or so?
Too positive, no, but I do think that we are now in the realm where, AI is now part of infrastructure, and that requires long-term planning, and that requires DC to get heavily involved. And so I think that there's a great reason why Jensen and team and NVIDIA are here in Washington, DC. AI is critical to compete globally, right, and we need Washington on board. And so I do hope that they understand that China is investing heavily, and if we don't want to fall behind, we need to remove the red tape. We need to enable investment, and that is the greatest thing that we could possibly do. So I would say building out data centers, so building power, enabling these data centers to be built. Those are the biggest kind of bottlenecks right now, outside of TSMC manufacturing GPUs. So that's the most critical part right now, and we need Washington, D.C.'s help.
Yeah, but to build a nuclear reactor is not going to happen even in the next 2 years or so. So what, if you could be more specific, like what do we need to do here in the U.S. to improve that power grid?
So I'd say remove the red tape, start investing today on power. Like that would be mission critical to get the job done.
And it sounds like that is the direction we're going towards, which would mean that the power suppliers in the United States, again, for the investors watching and the names, the stocks that trade on that, there's still ample opportunity for growth, right? So is that, I know you focus on chips, but this could be really bullish for
possibly.
Power.
I'm not sure what's priced into those stocks.
Then let's go back to NVIDIA really quickly. Just, you have earnings coming up. Is there anything major that you're expecting from the earnings report? I know we're a few years, and you haven't written your look ahead yet, your preview, I should say, but what would you be looking for?
I think what's most important really is that NVIDIA is sold out not only 2025, they're sold out 2026. So they have perfect line of sight to what they're going to do. And, at a very high level, we think they can do $8 of earnings next year. The street's at $6.50. If we're right, this stock is way too cheap, and it's going to push higher.
Do you benefit if you're right? Something like that?
I wish.
No, I'm just curious how it works behind the scenes.
Like, do you
get a big bonus if you're that much higher and you're right? But maybe that's an offline comment, not for the public. On that note, CJ Muse, thank you so much, guys. Back over to you.
Thanks for having me.
So, Patrick, what were some of your big takeaways from today?
Well, first of all, I appreciated us addressing the full stack, and who knows, maybe in a year there will be another element to the stack and we'll add another layer. I think it was just the comprehensiveness. I mean, we're going all the way from the investment funnel up front to literally building robots for homes and for commercial industrial applications.
I mean, for me, it was just an optimism for American AI.
Yeah.
Like, there's a reason we're doing this in Washington, D.C. They say that part of the success of Silicon Valley was that it was 3,000 miles away from Washington.
Right.
Today, everything is happening in partnership. I think this entire ecosystem is led incredibly by NVIDIA and Jensen, who now understand the importance of coordinating with Washington and coordinating with each other, right? We're taking on something that is 10 times the size of the Manhattan Project, that is of profound consequence to our national security, our national economic security. I think it was a great choice to do it here in Washington. And what we heard, I thought, was both sober about the path ahead, that it's not going to be a line straight up and to the right, but that we have these phases that we're going to go through in terms of AI. And I leave here a lot more confident about the path ahead for the U.S. And about the coordination between Washington and Silicon Valley.
Yeah, I'm with you there, Brad. I mean, the prosperity that we can provide, the diseases we can cure, and the amount of people we can put back to work, that's what I'm here for.
No doubt about it. So, Kristina, any final thoughts from you?
It seems just after the last conversation I had with CJ Muse that we're going to expect some positive outcomes from the conversations in China, especially with Jensen traveling overseas to Korea. So I think that's maybe a positive thing to read into this. The other thing is Nokia. During, maybe you were on the panel, so perhaps you didn't hear, the news came out about NVIDIA's investment, a $1 billion investment in Nokia. Shares were halted. And so this could speak to the collaborations with telecom and NVIDIA here in the United States and how we evolve towards 6G and how that will, just update through software. It's incredible. So I'm sure we're going to hear more about that news, but the stock was initially halted. And so that's something that just happened within the last hour or so. But overall, we're making news here. That's what this event is about, guys.
No doubt about it. It's a big day. We woke up with the, with the president in Japan making news. OpenAI and Microsoft made news, and we're going to hear a lot more out of NVIDIA in just the next hour or two. So we're out of time. It's been an incredible day. Yeah. Thanks to you, Patrick. Thanks to the entire team here at NVIDIA. Jensen Huang is about to take the keynote stage.
Brad, thank you. And our thanks to the entire NVIDIA team for bringing together this the amazing guests and all the folks from around the world for coming to NVIDIA GTC Washington.
Thanks for watching. Until next time.